Find the greatest common factor. Good day. For today's lesson is about the greatest common monomial factor. How to find the greatest common factor of a monomial expression. To find the greatest common factor or the GCF between monomials, first take each monomial and write its prime factorization. Then identify the factors common to each monomial and multiply those common factors together. Okay, to understand this one, let's take the first example. Our given example is 8x squared plus 16x. First, we're going to identify what are the given numerical coefficient. So from that, we have 8 and 16. And our literal coefficient are x squared and x. To find for the GCF for our literal coefficient, we must do a factorization of our numerical coefficient. For 8, the factor of 8 is 2 times 2 times 2. For 16, that is 2 times 2 times 2 and times 2. So as you can see here, this one is common to both of these numbers. Then write down below. Also with this one, they are common with that number, and also with this one, they are common. But this one is not, because there is no further number 2 for 8. So the result is 3. Thus, we will multiply this 3. So 2 times 2, 4 times 2, 8. So meaning to say that our GCF for our numerical coefficient is 8. For our literal coefficient, we must look at the exponent of each variable. The variable which has the smallest exponent, then that is our GCF for the variable. So for that, we have x. So our GCF for the whole is 8x, which serves as our divisor to get the other factor of the given expression. So to get the other factor, we must divide the first expression, which is 8x squared divided by x, 8x. So 8 divided by 8, that is equals to 1, or we must cancel this out because they are the same. Then for x squared and x, we will subtract the exponent of the numerator and exponent of the denominator. So the remaining for this is only x. So that is our first quotient for the given expression. Then we will copy the sign. Then next, the second term, which is 16x divided by 8x. 16 divided by 8, that is 2. X divided by x cancelled out because they are the same. So our last term in the factored form is 2. So the factored form of the given expression is 8x times quantity x plus 2. Okay. The second one, 12x squared minus 15x squared y to the 4th plus 45x and y raised to 5. So our numerical coefficient for this are 12, 15, and 45. And our variables are x cubed, x squared, and x. So as you notice, in the given, there is a y variable, but we do not include that one because this is not common to all the terms. So as you can see, this is our first term, second term, and third term. In the first term, we don't have y. That's why we do not include that one here. Okay, next, let us find the GCF of the numerical coefficient. So for 12, that is 12, 15, and 45. So the factor of 12 is 2 times 2 times 3. For 15, that is 3 times 5. For 45, that is 3 times 5 times 3. Okay, 3 times 5, that is 15, times 3, 45. Okay, so after that, we're going to find the common. For here, the common is only 3. 3. We need to say that our GCF for the general coefficient of the given expression is 3. Then for the literal coefficient is x. So x. Then our greatest common factor for that given term or expression is 3x becomes our divisor of the given expression to get the factored form of the given expression. Okay, let us try the first term, which is 12. 12x cubed divided by 3x, that is equals to 12 divided by 3, that is 4. X cubed divided by x, that is x squared. Y squared, because I said you have to subtract the exponent of the numerator and the exponent of the denominator. And then you write it in the first term of our factored form. Then copy the sign, the given sign. The next is the second term. The second term is 15x squared y to the fourth divided by 3x. Okay, 15 divided by 3, that is 5. For x squared divided by x, that is x. You have to subtract exponent of x, then exponent of x in the denominator. Then y, we will copy y because there is no y in the denominator. Then we write it there. Then the last one is 45 is y to the fifth. So, but first we are going to copy the sign. Then 45 x y to the fifth over 3x. 45 divided by 3, that is 15. Then x divided by x, that is none, cancelled out because they are the same. Then copy y to the fifth. Okay, so this is now our third quotient of our factored form. So that is now our factored form of the given expression. 3x times quantity 4x squared minus 5xy to the fourth plus 15y to the fifth. Okay, number 3. We have 25m squared plus 5m. Okay, let us identify the numeral coefficient. We have 25 and 5. And for the literal coefficient, we have m squared and m. To find for the GCF for 25 and 5, it has factored it out, 25 and 5. So for 25, that is 5 times 5. For 5, that is 5 times 1. So this is the one we are looking for. So 5. For the literal coefficient, we have the smallest one, this one, m. Okay. So now our GCF now is 5m. So we use that one as our common divisor of the given expression. Okay. So 25m squared divided by 5m, that is 5. Then m squared divided by m, that is m. Okay, that is the first factor quotient in our given expression. Then copy the sign. The given sign is this one. Then the last one, 5m over 5m. So this is cancelled out. This equals to 1. So you write it there. That would be our factored form of the given expression. Okay. The next, we have our given 100m cubed n squared minus 20m squared n plus 60n to the 4th. Our general coefficient are 100, 20, and 60. Literal coefficient, we have m cubed, n squared, n, and n to the 4th. We do not include the m, the variable m, because m is not common to all the given terms. Because in the last term, we have no m. To find the factor of 100, 20, and 60. Okay, for 100, that is 2 times 2 times 5 times 5. For 20, that is 2 times 2 times 5. Then for 60, that is 2 times 2 times 5 times 3. Then let us find the common. The common is this one, 2, also this one, 2, also with this one, which is 5. To multiply this 3, we have 20. So that is our GCF for the numerical coefficient. For our literal coefficient is n. So to combine it, we have 20n. Then that would be our divisor of the given expression to get the factored form. Okay. 100 m squared, m cubed divided by 20n. So 20 divided by 100 divided by 20, that is 5. Then this one, we have n here, n squared. So for m, we do not have m in our denominator, so we will just copy m cubed. For n squared divided by n, that is n. It is the first quotient. Then copy the sign, negative. The next is 20m squared n divided by 20n. So if we're going to subtract or divide this one, that is 1. Cancel na siya. So m, we don't have m, so we will write m squared. Then n cancelled out. So the answer is only M. Then copy the sign, the given sign, then 60 divided by n to the fourth divided by 20n. So 60 divided by 20, that is 3. Then n to the fourth divided by n, that is n cubed. So that is our final quotient of the given expression. So this is now our factored form of the given expression. 20n times quantity 5n cubed n minus n squared plus 3n cubed. Okay. The last number. We have 32a to the 6 minus 8ab minus 80a cubed b squared. The given numeral coefficient are 32, 8, 80. Literal coefficient, common, a e to the 6, then a cubed, then a. Then first we're going to find what is the common factor of 32, 8, and 80. For 32 we have 2 times 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. Okay. And 2 times 2 times 2, 40 times 2, that is 80. Okay, after that, we're going to find the common. This is the first 2. Then multiply it by this common 2 and also with this common 2. So 2 times 2, 4 times 2 equals to 8. That is our GCF for the numeral coefficient. Then for our literal coefficient, we have A. Okay. So after that, we're going to make that one as our GCF or divisor of our given expression to get the whole factored form. Okay, we have this one. Okay, first divide the first term, which is 32 a to the 6th divided by 8a. That is 32 divided by 8. That is 4. Then a to the 6th divided by a. That is a to the 5th. Okay. Then after that, we'll copy the given sign. Then for the second term, we have 8ab divided by 8a. That is, this one is cancelled out, and also with this one, then the remaining is only b. Okay, then copy the given sign. So, okay, last one, 80 a cubed and b squared over 8a. So 80 divided by 8 is equals to 10. A cubed divided by a, that is a squared. Then copy b squared. Okay, that's it. That is our factored form of the given expression. So this is a detailed way on how to find the factor of a given expression. Okay, how to solve it directly or in a shortcut way method without undergoing with the detailed process. So simply you look at for this one and this one. Okay, what number can factor all of this? So for this one we can say that 8, this number can divide 8 by itself and 16. So let's write 8, then the exponent is x. the variable is x, because x is the variable which has the smallest or the smaller exponent from this expression. Okay, so we divided by 8x squared by this x, that is x. Then copy the given sign. 16 divided by 8x, that is 2. For this one, 12, 15, and 45, that is 3. If the variable, how about the variable? The variable is x cubed, x squared, and x the smallest one. Then you divide 3x, 12x cubed divided by 3x, that is 4x squared. Then copy the sign. Then 15x squared divided to the fourth by 3x, that is 5y of x, then y to the fourth. Then copy the sign, positive. Then for 45, xy to the fifth, that is, you divide it by 3x, that is 15. Then y to the fifth. Then this one, we have 25m squared and 5m. The number that can divide both of them is 5. Then the smallest variable is m. Then we divide 5m by this one, that is 5m. Then copy the sign, then 5m divided by 5m, that is 1. And for this, the number that can divide all of these three variable is 20. If 20 can divide all 100, how about the variable? The variable common is n. So n is the smallest, no? Having smallest exponent. So n. So 100m cubed and 100m cubed n squared divided by 20n. That is 5m cubed n. Copy the sign. This one. 20 divided by 20, that is 1. Then 20m divided, well, we don't have m, so we write m squared. Then n cancelled out. Then copy the sign. 60 divided by 20, that is 3. Then m to the 4 divided by n, that is n cubed. Then for this one, so 32, 8, and 80, we know that 8 can divide 32, 8 by itself, and 80. So this is 8. Then for a, we have a. For b, we do not include b because b is not common to all. So this is now our divisor. So 8a divided by 32, a to the 6, is 4. Then a to the 5th minus 8ab divided by 8a, that is only b, because we cancelled 8 and 8 in a and a. Then copy the sign. Then 80 divided by 8 is 10. Then a cubed divided by a, that is a square. Then b, we will copy b squared. Okay, that's all. So as you can see, it's very easy to you to solve if you are already familiar with the factoring way of polynomials. Okay, for now, I'm saying thank you for watching my video. Hope you learned something about this. Thank you and God bless. Hello, good day. For today's lesson, it is about the difference of two squares factor. Remember that to factor the polynomial that is the difference of two squares is the sum and difference of the square root of the first and last term. That is in the form of a squared minus b squared is equals to the quantity of a minus b times the quantity of a plus b. So take note of that form. And then, if you have time, please familiarize this table. This could help you to solve the different uh, problems in relation to the difference of two square factoring. So I have here 5 examples to solve for. Okay, let's take the first one. The first one is x squared minus y squared. Okay, the first step is to find the square root of the two terms. For the first, we have y squared and y squared. So the first term, what is the square root of x squared? That is x. For y squared, that is y. Then after that, you just form x, distribute x into two parentheses or two quantity, then copy the negative sign. Then here is opposite sign. Then the last one is the square root of the last term. Okay, that is the answer. So in this way, we are making a detailed way, which I showed to you how I got this one. So that is the answer, our factored form. So without making this part here, we can solve it directly without showing this part. So to do that, the same procedure, the same given, we can solve that by just writing from the given x squared minus y squared by just writing two parentheses. Then find the square root of the first here, then copy the sign, then square root of the last term, which is y and y. Here is positive and y. Then that is the answer. Then the second one. So the square root of the first term and last term. Our first term is p squared, then second term is 64. So what is the square root of p squared? That is p, then 64 is 8. So we'll just write two parentheses. Then that is p, then p. Then we will copy the sign negative. Then here is positive. Then square root of 64, that is 8 and 8. Then that is the answer. It's the factored form of the given. Okay, without showing the detail, we'll just write equal, then parentheses, two parentheses, then take the square root of p, which is p and p. Then copy the sign, negative. Here is positive. Then square root of 64, that is 8. Here is 8. Okay. Then that is the answer. The factored form of p2 minus 64. Number 3. So the same, we have to identify the first term and the last term and their square root. Our first term is 121. Then the second term is y squared. So for 121, that is 11. For y squared, that is y. And after that, form a parenthesis. So we will write the first square root for the first term, then also with here. Then copy the sign, negative, then square root of y is y. Here is positive, then y. Then that is the answer. It's a factored form. The next is, without making the details, then we'll just write two parentheses, then find the square root of 12, that is 11, 11. Then sign, then here is opposite. Then square root of y, that is y, here is y. This is the answer. Okay. Number 4. The same, find identify the given, the first term, and the second term. For the first term, we have a squared and b to the fourth, and the last term is 81. So what is the factor of each? For a squared is a, for b to the fourth is b, for 81 is 9. Then form two parentheses. So we have this one, a, b, a, b. Then this given sign, opposite sign. This one is 9 and this one is 9. That is the answer. So okay. So without doing this part, we can solve it by just writing equal sign, two parentheses. So remember that if the given is look like this, then you can solve it in this way. So first, we're going to identify what is the square root of this one. For a squared, that is a. We write also a here. For b to the fourth, that is b squared. Here is also b squared. Then copy the given sign. Then here is opposite. For 81, that is 9. Also here is 9. So that is the answer. The factored form. This is negative. Okay, next number. Okay, for the fifth one, we have 9 over 16 r to the fourth minus 1 over 5 n squared, it is squared, then n to the 9. So for the first term, we have that one. The second term, we have this one. So first, we're going to find its square root. For 9, it is 3. For 16, that is 4. For r to the 4, that is 4 squared. Then 1 over 5, that is 1 over 5. 1 over 5 or 1/5. Then t, this one is in cube. So form two parentheses, then distribute the first term square root and the last term square root. Okay, 3/4 r squared, then 3/4 r squared, then given sign, here is opposite, then the square root of the second term, which is 1/5, 1/5 t in cube, 1/5 t in cube. Okay, that is the answer. Okay, and next is, to solve it without making the detail, so we'll just write two parentheses. So 9 over 6 or 9/16, we'll just find the square root of 9. 3. Square root of 16, that is 4. Then we'll write also here 3/4. Then square root of r to the 4th, that is r squared. Then copy the given sign. Then here is opposite. Then 1 to 1 to the 25th. For 1, we have 1. The square root of 1 is 1. The square root of 25 is 5. We also write it here. Then square root of t, that is t. The square root of n to the 9, that is n cubed. Also write it here. Okay, that is the factored form of the given. Okay, so that is how we're going to factor the difference of two squares. Hope that this video would help you a lot in solving your mathematics subject. For this, I would say thank you for viewing my video and God bless. Keep safe. Good day. Today we're going to talk about sum and difference of two cubes factoring. So in finding the factor of sum and difference of two cubes, I suggest to familiarize this table. We have the square, we have the squares, the square root, and its cube. Okay. So this one, we will just focus our attention here. This is the cubes of a number, Then this is the equivalent value for these cubes. So in finding for the cube root of a number, say for instance 8, you just look for the base of the cube. This one, 27, this one, 64, this one, 125, this one, 216, this one, and so on and so forth. So, for example, you encounter a problem asking you to find the square root of this number, let's say 27. Okay, what is the square root? What is the cube root of 27? Meaning, what number to be multiplied 3 times in order to get 27? So, this is 3. Why 3? Because when you multiply 3 by 3 times 3, it is equals to 27. Or simply in exponential form, 3 cube, 3 the base, then 3 cube is equals to 27. As I said, we look at the base as the square root or cube root of 27. Okay, so in solving for sum and difference of two cubes, we have two patterns to be followed or to choose. Okay, the first problem is number 1 is x cubed plus 8. So first you have to find the cube root of this term. That is a very important matter in solving for the factor of sum and difference of two cubes. Okay, what is the cube of x squared? That is x. Why x? Because when you multiply 3 times x, that is equivalent to x cubed. Why x cubed? Because as we know that a variable is always having an exponent 1. No? A variable with no exponent is considered having an exponent of 1. So when you multiply variable, you simply add the exponent. 4, 8 is 2. Because when you multiply 2 3 times by itself, that is equals to 8. So this is our A, this is our B. And then What is the pattern? So this is positive, so we look for the sign here. So since this is positive, we will use this one. Okay, open parenthesis, the value of A is X, the value of B is 2. Then it says that we have to double the value of A. The value of A is X. The value of A is X. Then opposite sign. Then it says we have to multiply the value of A and the value of B. So quantity X times quantity 2. Then next is positive. Then we will double the value of B. Value of B is 2. Square. Okay, simplify. X copy the first quantity. And this one, that is X squared minus the product of 2 and X is 2X plus 4. Okay, this is the answer. Okay, next given is 27A cubed minus 1. So first we have to find out the cube root of this term. The cube root of 27 is the cube root of 7 is 3. The cube root of A squared is A. The cube root of 1 is 1. Okay, this is our A. This is our B. So what pattern to use? Negative. Negative ini. Okay. Open parenthesis. What is the value of A? 3A. Plus minus the value of B, which is 1. Then it says we have to double the value of A, that is 3A. Then plus the product of A and B. For A we have 3A. Then 1 for B. Then plus the value of B to be doubled. The value of B is 1. Then square. So we'll just copy the first quantity. A minus 1. A minus 1. Then square of 3, that is 9. Square of A squared. Then plus product of 3A times 1, 3A. Then square of 1 is 1. Okay, this is the answer. Okay, next number. M cube plus 125. Simply find the cube root of each. M cube is M, 125 is 5. Then what pattern to be used? This one, positive, so this is the pattern to be used. What is the value of A? M. Value of B is 5. Then value of it to be doubled, M. Then minus opposite the product of the value of A and the product of the value of B, which is 5. Then we have to double the value of B, which is 5. So next is we will copy the first term, M plus 5, then M squared, then the product of M and 5, that is 5M, then plus the square of 5, that is 25. Okay, this is the answer. Okay, next, number 4. Given x squared x cubed plus y cubed. Okay, same, find the cube root. For y cubed we have x. For x cubed, x. For y cubed is y. This is our a, this is our b. So what pattern to use? Still number 1. Yeah. So open parenthesis, the value of a is x, the value of b is y. Then from the pattern, a must be doubled, so the value of a must be doubled. Then opposite sign, minus the product of a, value of a and b. The value of a is x, the value of b is y, plus double the value of b, which is y. Okay, so copy the first quantity, then this one x squared, then the product x and y, xy plus y squared. Okay, this is the answer. Next. Okay, the given is 5 cubed minus 8y cubed. So simply just find the cube root of this term. For x we have this one, x. The cube root of 8 is 2. The cube root of y cube is y. This is our a, this is our b. Then what pattern? This is pattern to be used. Phase is negative. So open parenthesis, the value of a is x, the value of b is 2y. Then the value x to be devolved is x. Then opposite sign, positive. Then the product of the value of a and the value of b. Then plus the double of the value of b. What's the value of b? The value of b is 2y. This is 2y squared. Okay, so simplify. Copy the first quantity, x2y, then x squared, then plus 2xy plus 4y squared. Okay, that's it. Okay. Okay. Number 6. So the given for number 6, look at the given. We cannot find the square root of the cube root of 2. We cannot find the cube root of 28. So all you have to do is to factor this first using the common monomial factor. Okay. What is common for this? Only the numbers. What is the greatest common factor of 2 and 28? So that is 2. Okay. 2. 2y divided by 2y cubed divided by 2, that is y cubed. Then for 28 divided by 2, that is positive 64. Okay, after that we'll find the cube root of its term. Okay, the cube root of its term for the first term is we have x cubed y 64 is 4. Why 4? Because we multiply 4 times, that is 4 times 4, 16 times 4, 64. Okay, so this is our A, this is our B. Okay, what pattern? This one. Okay, our A is y plus value of B 4. Then the value of E is to be double, value of E, A. Then opposite sign, the product of A and B. Say y, quantity y times quantity 4 plus the value of B must be double, 4. Okay. Then here, you copy 2 here. See, bring down 2y plus 4. Then this one, x, no, not x, y. This is y squared minus the product of these two, y times 4, 4y plus 16. Okay, this is the answer. Okay, that's it. Okay, so this is the detailed procedure solving for the factor of sum and difference of two cubes. Now we're going to use the shortcut method. So our first given is x cubed plus 8. So first we have to find out what is the square root of the first and second. Okay, so for x cubed we have x plus the cube root of 8, that is 2. Then after, we have to square the value of the x, value of a, which is x. This will become x squared. Then opposite sign. Then the product of the first and second term, which is x times 2. So this will become 2x, then plus the square of the last term, which is 2. It will become 4. Okay, for the second, we have 27a cubed minus 1. The same, find the cube root of 27, that is 3. Cube root of a cubed, that is 8. Then copy the sign. Cube root of 1 is 1. Then next, double or square the value of the first term, that is 3a. So it will become 9 and a squared. Opposite sign, positive. Then product of the first and last term, so 3a times 1, that is 3a. Then positive or plus the square of the last term, which is 1. So 1 times 1, that is 1. For the third example, we have m cubed plus 125. The cube root of m cubed, that is m. Then sign plus the cube root of 125 is 5. Then the square of the first term is m squared. Then opposite sign. Then the product of the first and last term is 5m. Then sign plus. Then the square of the last term, which is 25. Then the fourth one is given is x cubed plus y cubed. So the cube root of x is x, the cube root of y cube is y. Then we have to square the first term, that is x squared, and opposite sign. Then the product of the first and last term is xy. Then plus the square of the last term, y squared. Then for the fifth, we have x cubed, then 8y cubed. Then we have to look for the square root of the first term. This x, copy the sign. Then 8 is 2. Then y cubed is y. Then next is square the first term. So x squared, then opposite, then you multiply the first term and second term. This is 2xy, then plus the square of the last term, 4y squared. And the last term is, and the last one is so 2y cubed plus 128. So as you can see, we could not find the cube root of 2y. We can find the cube root of y, but for 128 there's none. So we have to find out the common, we have to find out the factor of these two using the monomial factoring method. So for this, y, our variable is not common to these two terms. We have only to focus on the numeral numbers. So we have 2 and 128. So what is the greatest common factor for 2 and 128? So that is 2. So 2. Okay. 2y cubed divided by 2, that is y cubed. Then copy the sign. Then 128 divided by 2, that is 64. Okay. So now, we just copy number 2. Then, we are going to find what is the cube root of the first term. The cube root of y cube is y, plus the cube root of 64 is 4. Then next, we have to find the square of the first term, which is y. So y squared. Then opposite sign. What is the product of y and 4? That is 4y. What is the next is plus the cube, the square of the last term, which is 4 squared is 16. Okay, that is the answer. So you have just seen the detailed and shortcut method for the factoring of sum and difference of two cubes. Hope that this would help you to find comfort in factoring sum and difference of two cubes that you might encounter in your mathematics subjects. For now, thank you for viewing my video, and please don't forget to subscribe my channel, Wronski Kamski. Thank you, and God bless us all. Keep safe. Hello, good day. Today we're going to talk about perfect square trinomial. How to identify that a given trinomial is a perfect square trinomial, and how to find its factor. The perfect square trinomial is a result of squaring a binomial. A perfect square trinomial has a first and last term which are perfect square, and a middle term which is twice the product of the square root of the first and last term. Okay, to understand this one, let us take these examples. Number 1. we have m squared minus 12m plus 36. First, we have to find out what is the square root of the first and last term. As you notice, our first term is m squared and our last term is 36. So what is now the square root of m squared? That is m. For 36, that is 6. Okay. In order to know that the given trinomial is a perfect square trinomial, we have to multiply the square root of the first and last term. That is 1 times 6 equals to 6 times 2, that is 12. So as you can see, this result is equals to our middle term. So all you have to do is to automatically write the parenthesis squared containing the square root of the first and last term, separated by the sign of the given trinomial, which is negative 1. That's the answer. Okay, next one. The given is 16d squared minus 24d plus 9. So the first is to find the square root, the first and last term. The 16d squared, the square root is 4d. For 9 is 3. And to find if it is really a perfect square trinomial, we multiply the first and the last term. So times 3 equals to 12 times 2 is 24. So this is equals to our middle term. So that means that is a perfect square trinomial. So 4d minus 3 squared is now our answer to the given trinomial. Okay, next problem. The given is 9x squared minus 30x plus 25. So as usual, you're going to find the square root, first and the last term. So for the first term, we have 9x squared and the last term is 25. For 9x squared, our square root is 3x. For 25 is 5. Now we're going to determine if it's really a perfect square trinomial by multiplying the square root of the first and last term. This is 3 times 5 equals to 15. Then times 2, that is equals to 30. This one is equals to our middle term. So this is a perfect square trinomial. So we will write the parenthesis containing the square roots. Then sign is negative 5 squared. That is the answer. Okay, next. The given is 27 squared plus 72xy plus 48y squared. So as you notice, the first square root is not a perfect square, and also with the last. So all you have to do is to find first the factor using the greatest common common factor of the given trinomial. So for this 27, 72, and 48, it is 3. Then 3 divided by 27 divided by 3, that is 9 x squared. For 72, that is 24 x y. For 48, that is 16 y squared. Okay, that is now our basis. For our first term, we have x squared. For the last term, we have 16 y squared. So what is their square roots? For 9x squared, that is 3x. For this one, 4y. Then we will try if it is really a perfect square trinomial with this one. Okay, that is 3 times 4 equals to 12 times 2 equals to 24. Yes, it's true. So you will just write first this one, 3. 3 times 3x. What is sign? Positive. So this is positive 4y squared. That's the answer. Okay, the last one. So same now, same siya. Because yes, 4 we can find the square root of 4, but not for 100. We can find 100, but for b there's none. So we have to find the square, the factor of this using the common monomial factoring. So for this we have 4. No? 4 can divide all of these numeral coefficient. Then what are commons in the variable? Only b. So we'll write b. Okay, 4a squared, b divided by 4b, that is a squared. Sine 40ab divided by 4b, that is 10a. Then plus 40 divided by 4, that is 25. Okay, 25. Now, that's the time that we're going to find the square root of that trinomial. For a squared and 25, for a squared we have a, for 25 we have 5. Let us check if it is a perfect square. So 1 times 5 equals to 5 times 2, that is 10. Okay, this equals to the middle term. So all I have to do is to write 4ab, then inside a minus 5 squared. This is the answer. 4ab minus, okay, check. Okay, next. Okay, this one, our solution is a detailed solution for a given perfect square. Now, how to do it in a shortcut way? So here is the problem that we had taken a while ago. So we will make a shortcut method for this. Okay, the first given is this one. So same, we're going to make a parenthesis 10 squared. Then take the square root of the first term, which is m squared. So m is square root. Then sign is negative. And 36 is 6. That's all. For let's check kung perfect square ba ang square root o ang given trinomial by multiplying this one. 6 times 6, 6. 1 times 6 is equals to 6 times 2 is 12. So correct. Equals yan eh. So for number 2 we have 16. Now 16, that is 4. For this square, that is d. Minus 4, 9, that is 3. And squared. Okay, let us check. 4 times 3 equals to 12. Times 2 equals to 24. Okay, correct. This is a perfect square trinomial. And our answer is correct. How about number 3? Our first term is 9 squared. So this is 3x minus 25 is 5. Square root of 25 is 5 squared. Okay, let us check. If this is a perfect square, 3 times 5, that is 15. Times 2, that is 30. Okay, correct. 27. So as I said in a previous detailed solution, we have to find their factor using the greatest common factor. For 27, 72 and 48, that is by 3. So 27 divided by 3, that is 9 x squared. For 72, that is 24. Xy plus 48 divided by 3, that is 16. Y squared. Okay. Then we will write here 3. Then what is the square root of 9? X squared, that is 3x. Positive, so this is positive. Then what is square root of 16? That is 4. How about y squared? That is y. Okay, that is the answer. So we will check if it is really a perfect square trinomial, so that we can decide that this is really correct. So we will multiply 3 times 4. 3 times 4 equals to 12 times 2 equals to 24. Okay, correct. The last one. So as you can see, this can be 4 can be, there is a square root for 4, 40 and 100, that is 10. But for B, A, and B, there's none. So we'll find the factor using the greatest common monomial factoring, or greatest common monomial factor. You see, the factor for 4, 40, and 100 is, that is 4. Okay, what are the common? B. Okay, that is our divisor now. So 4a squared b divided by 4b, that is a squared. Then for 40, that is 10a. Then plus 100 divided by 4, that is 25. Okay, that's it. So our answer is, we'll copy this first, 4b, then the square root of a squared a, then sign is negative, minus the square root of 25 is 5. Okay, we will check if this is really a perfect square trinomial. So we will multiply 1 times 5 equals to 5 times 2 equals to 10. Correct. So this is now the shortcut method in solving for the perfect square trinomial. So as you can see, the time that you allotted for this is shorter than the detailed one. But I show these two methods so that you will understand, especially the one who are starting to learn about factoring a perfect square trinomial, especially the graduate students. So for now, I thank you for viewing my video. I hope this video that would help you, especially the grade 8 students, to solve mathematics problem, and also with other interested person that this video would help them in their subjects, because this is a foundation for the algebra, foundation for algebra, which can be carried on up to the higher level education. So I hope this would help you a lot, and thank you for that. I hope this would help you more as you go on your study. So thank you, and please don't forget to subscribe my channel, Ronski Kamski, and may God bless us all. Keep safe, everyone. Today we'll be talking about general trinomial factoring. To factor general trinomial, we have these two forms. Take note of these two forms in solving for the factor of general trinomial. The first one is this one: ax squared plus bc plus c, where a is equals to 1. Take note of a value. A value should be equal to 1. So there is a technique that we are going to use when the value of the numerical coefficient of a given trinomial is equals to 1. we have a certain technique for that, and also with this one when the value of a is greater than 1. Okay, let's start with the first form where a is equals to 1. Here are the examples. Let's take the first one. The first example is x squared plus 7x plus 12. Okay, all you have to do is just look at the last term. The last term is positive 12. So all you have to do is to look for the factor of 12. So we all know that the factor of 12 is 1 and 12, 2 and 6, and 3 and 4. So if we're going to multiply this one, this is 1 times 12, that is 12. 2 times 6 is 12 also. 3 times 4 is 12. Okay. All you have to do is to find the sum of its factor. If the sum is equals to the middle term, then that means that that combination of factor is the one we are looking for. Okay, this one is 12 and 13. This one is 8, and this one is 7. So as you can see that this 7 is equals to the middle term. So we will use this combination, positive 3 and positive 4. So all you have to do is to write two parentheses or two quantity, then find the square root of the first term. So when we say x squared and its square root is x, so we will distribute x here on the first parenthesis as well as the second parenthesis. Then we'll put these 3. Since these are all positive, then we write positive 3 and positive 4. Okay, this is the answer. Okay, how to check if your answer is correct? Okay, that is by multiplying this factor using FOIL method. So we multiply x times x, that is x squared, then x times 4, that is plus 4x, then 3x plus 3x, then 3 times 4, that is positive 12. Combine all like terms, x 12, then 4x plus 3x is positive 7x, then the last one is positive 12. And to say that our answer, quantity x plus 3 times quantity x plus 4 is correct, because when we multiply that answer, we will get this product same as the given. Okay, next. So the second given is x squared minus 7x plus 12. As you can see, all the terms are just the same with the number one example. The difference is only the sign, negative 7x, and this one is positive 7x. So what will happen to the answer when the second term is negative? Okay, so same now, the last term is 12, so we will look for the factor that will answer negative 7. So in our previous example, the factor that will answer positive 7 is 3 and 4. 3 and 4, that is 7. But it is negative. So all you have to do is change this one to negative and change 4 to negative. So the answer is negative 7. Okay. So same as usual, we are going to find the square root of x squared, which is x. So we distribute x, then x, then next is negative 3, no? Diba? Negative 3, negative 3. So negative 3, then the second one is negative 4. So this is the answer now for the second example. This is the factored form. Now let us check using FOIL method if this answer is correct. As I said, you have to multiply it using FOIL method. So x times x, that is x squared. Then x times negative 4, that is negative 4x. Then negative 3 times x, that is negative 3x. Negative 3 times negative 4, that is positive 12. So combine like terms, x minus 7x plus 12. Okay, correct. Okay, mean to say that this answer is correct. Okay, next. Okay, the given is, as you can see, the difference is that all are negative, no? All are negative. So we will try to find the answer. So it seems well you take this number, the last digit, because as I said, when the numeric coefficient of the first term is equals to 1, then we will only consider the last term. So our last term is negative 12. So what is the factor of negative 12 in order to get negative 1? So let's say 4 times 3. Okay, 4 times 3 is 12, positive 12. Then let's say 4 and negative 4 and 3, or positive 4 and negative 3. These are 12, no? This is positive 12, so we divide into this one. Okay. Negative 4 times 3 is 12, positive 4 and 3 is negative 12. So if we're going to find the sum of these two, negative 4 and 3, that is negative 1. 4 plus negative 3, that is positive 1. Okay, which of this is qualified for this? Negative 1. So this combination. So we have to do is to write to parenthesis, then find the square root of x squared, that is x, distribute, then what is sign? Negative 4, then positive 3. Okay, that's the answer. Next, we will check if this answer is correct. So x times x, that is x squared, negative 4 times x, that is negative 4x, then 4x, no. Okay, x times x, that is x squared, x times 3, that is positive 3x, then negative 4 times x, that is negative 4x, and negative 4 times 3, that is negative 12. So combine all like terms, we have negative x, then negative 12. So is this the same with the given? Okay, let's say that this answer is correct. Number 4. Number 4 is x12 plus x. Before, this is negative, so this time our x is positive. So again, we are going to look for the factor of negative 12. So still we use 3 and 4 as the factor of 12. So if this is negative and if this is positive and 4 is negative, what will happen? So this is 1, this is negative 4, negative 1. If we're going to find the sum. Okay, what combination is qualified for this? Okay, this one, this option. Okay, so let's try now. Find the square root of x squared, that is x. So your answer will be x. This is also x. Then the sign of 3 is negative. Then sign 4 is positive 4. Okay, that's the answer. Okay, so how to check if same as usual now, we are going to check using FOIL method to check if our answer is correct. So x times x, that is x squared, then x times 4, that is 4x, then negative 3x times 3, that is negative 3x, negative 3 times 4, that is negative 12. Combine like terms, this is squared plus 4 plus x, then negative 12. So you try to compare, compare. So they are the same. You say that this answer is correct. Okay, number 5. Okay, number 5 is different, we changed the middle term, but the first and the first and the third term is just the same. So how would be the answer? How would be the answer look like? Is it the same with the others, or let's say we will try. Okay, the same, positive 12. Look for the last term, positive 12. Then what is the possible answer? Let's say 1 and 12, 2 and 6, 3 and 4. So if we're going to multiply this one, these are all equals to 12. But if we're going to add this one or find its sum, what is the answer now? 1 times 12, 1 plus 12, it is 13. 2 plus 6, that is 8. And 3 plus 4 is 7. Okay. So which of this is equals to the middle term? So this part. Okay. So if this is equal to that one, so our answer will be same as usual, by the square root of the x, that is x. Distribute x. Then positive 2, positive 2. Positive 2. This also is positive 6. Okay, the answer is quantity x plus 2 times quantity x plus 6. That's the answer. So how to know that this is correct? So you multiply that one using FOIL method. So multiply x times x, that is x squared. X times 6, that is positive 6x. 2 times x, that is 2x. Then x times 6 times 6 is positive 12. Combine like terms, that is x squared plus 8x plus 12. So this is the answer. This is the product of multiplying our result. So mean to say, as we compare this answer is checking to our given, they are the same, meaning this answer is correct. Okay, that is how to answer, how to factor general trinomials where your first term numerical coefficient is equals to 1, or is A. Now, the second one, factoring general trinomial using this form where A is greater than 1, meaning the numerical coefficient of the first term is greater than 1. Okay, let's try that one. So I have here given 6x squared plus x is 6x squared plus x minus 2. Okay, so the first move is we're going to multiply the first and the second term. Okay, that is 6 times negative 2 equals to negative 12. Okay, next is find the factor, then select which combination from the list satisfies the middle term. Okay, factor of 12. Okay, negative 12. Okay, what are the factors of 12? What are the factors of 12? Okay, the factor of 12 are 1 and 12, 2 and 6, 3 and 4. 3 and 4. Okay, so if I'm going to multiply this one, this is positive 12, negative 12, so maybe one of this is negative, something like that. Okay, negative 12. If we're going to multiply 2 and 6, that is positive 12. So we are going to make any of this as negative to make it 12, negative 12. For this, we're going to multiply this one 3 times 4, that is 12. But the number that we're going to factor is negative 12. So we're going to make one of these as negative. So negative 3 times 4 is negative 12. So if we're going to find the sum of that factor, this is 11, this is negative 4, this is positive 1. So if we're going to compare this answer to the middle term, this is the correct one where their sum is equals to the middle term. So you use this one as one of the items in the factor of the given trinomial. Okay, so factor of x squared is x. Then we're going to copy the given. We're going to copy the given and replace that middle term with the one that we are, with the factor that we have chosen. So 6x squared, instead of writing this one, we will write this factor, that is negative 3x, positive 4x, then minus 2. After, we are going to group this one, group by 2. Then after, we will find the greatest common factor or the GCF of the two groups. So for the first group, 6x squared and 3x. So for the numerical coefficient 6 and 3, the GCF there is 3, and each variable, we look for the variable which has the smallest exponent, which is the x. So we will write x, and then divide this group by this GCF. So 6x squared divided by 3x, that is 2x, and 3x divided by 3x, that is negative 1. And for this one, our greatest common factor for 4 and 2 is 2. Okay, 2. And then we will divide them with this 2. 4x divided by 2, that is 2x. 2, negative 2 divided by 2, that is negative 1. Okay. As you notice that the quantity or the quotient of the first group and the quotient of the second group is the same. So that is now your hint that answer is now closer to the correct one. So we'll copy this common. 2x minus 1, then the last one, 3x and positive 2. 3x and positive 2. Okay, this is now our factored form of the given trinomial. Okay, ini siya. This is 2. This 2. Okay, next. Okay, we will check if that answer is correct by multiplying it using the FOIL method. Okay, 3x plus x quantity, not x, this is 2, that is 2. That is 2, and this is 2. This is 2. Then 2x minus 1. Okay, we multiply 3, that is 6x squared. Then 3x times negative 1, that is negative 3x. Then 2 times 2x, that is positive 4x. Then negative positive 2 times negative 1, that is negative 2. So combine like terms. This is negative 3 and positive 4, that is positive x, then negative 2. Okay, look at the answer. Look at the answer. Look at the product. Is it the same with the given? If it is the same, then our answer is correct. Yes. Okay. Number 2. The given is 2x squared plus 10x plus 12. So as usual, you multiply the first and the last term. 2 times 12 equals to 24. Then you look for the factor of 24 that could make that when you add it is equals to 10. So the factor of 12 is 2 times 12, then 3 times 8, and 4 times 6. Okay, so if we're going to find the sum of this, 2 plus 12 is equals to 14, which is more than 10 in the middle term. Then this one, 3 and 8, it is 11. is more than the middle term. For the last one, this is equals to 10. So I mean to say, this is the one we are looking for. So we will rewrite the given trinomial 2x, then instead of the middle term 10x, we will write these two factor plus 4x plus 6x plus 12. Okay, then after that we will combine. Then after, we're going to find the GCF of the two group. For the first group, 2x squared and 4x. For 2 and 4, that is 2, the GCF. For the variable x, then we will divide 2x squared divided by 2x, that is x. Then plus 4 divided by 2x, that is 2. Then for this one, what number can we use to divide both? That is 6. Okay, so the variable is not common to these two terms, so we will use only 6 as their divisor or their GCF. So 6x divided by 6, that is x. Then copy the sign. Then 12 divided by 6 is 2. Okay, next is we will copy this common, no? X plus 2, then this one and this one, 2x plus 6. Okay, this is the answer now. Okay, so to check, no? To check, the same as usual, we're going to multiply the factor using the FOIL method. Okay, let's try. Okay, quantity x plus 2 times quantity 2x plus 6. We will use the FOIL method, that is x times 2x, that is 2x squared, then x times 6, that is 6x, then 2 times 2x, that is positive 4x, then 2 times 6 is positive 12. Then combine like terms, 2x squared plus 10x plus 12. Okay, that's it. Compare. Are this product of the FOIL method the product of the factored form using the FOIL method is the same with the given? Okay, they are the same, meaning to say this answer is correct. Okay, that is how to solve for the general trinomial. So always take note that when the numerical coefficient of the first term is 1, you can easily solve for the factor of the trinomial. But if the numerical coefficient of the first term is greater than 1, then you undergo with grouping method. Your process will undergo a grouping in order to find the factor of the given trinomials. Okay, so if you have some question of this presentation, you may write some comments below. Then for those who are not yet or can't understand some parts of this video, you can replay this one. And please don't forget to subscribe my channel so that you can be updated with a new incoming video that will be made. So for now, thank you for viewing my video, and good luck and God bless. Good day. Today we're going to talk about multiplication of rational algebraic expression. In multiplying a rational algebraic expression, we must have a knowledge of the law of exponents and know how to factor polynomials. Okay, we have the first given or first example. So 12 over 20. So first we have to find the factor of the numerator and denominator. For 12 we have 4 times 3, and 20 is 4 times 5. So as you can see that 12 and 20 are common of 4. So this will be cancelled out. So the answer or the remaining is 3/5. So this is the answer for example number 1. For number 2, the same, no? We have to factor out. Before multiplying, we have to factor out and apply the cancellation method. 3 over 5 times 5. Why times 5 times 5? Because when you multiply this one, the result is 25. Then multiply by 5 over 3 times 3. So this will be cancelled. 5 also cancelled, and 5 is also cancelled. So the remaining is 1 over 15. Where I got this one? Because upon cancellation, one number, it's always 1, 1, and 1 also here. So when you multiply 1 times 1, that is 1. Is here 5 times 1, 5 times 1, 5 times 3, 15. So this is the answer. Okay, example number 3. Okay, same as usual, you factor the numerator over 3 times y times 3x x. Y we have 2x because it is 2 squared, and 4y we have also 2y's. Then over 2 times 5. So we will cancel the common factor. So for 2 we have 2 here, have 2 here. We have 1, we also 1. We have y, we have also y. Okay, there's none. So we will combine all. 2x. Here we have 2x. And copy. Then we have y. Then over here we have 5. Okay, simplify. 2x, how many x's? 1, 2, 3. So x cubed, then y over 5. So this is your answer for that problem number 3. Okay, number 4. Okay, the same, we have to factor out each. That is 5 times t over 2 times 2 times 2. On the upper side, 2 times 2 over 3 times t times t equals, not yet, we have to cancel out the common. First we have this one, this one, this one, and this one, this one, and this one. So what is left here is 5, then 3 times t. Okay, what is the answer? That is 5, 3, t. Ano na pa? Times 2. Times 2. So this is 6. 5 over 60. Okay? Okay, this answer. Okay, number 5. For number 5, the same, no? We are going to factor 9, that is 3 times 3. For A, we have 2 squared. B, no. We have to factor A also. Times A, then times B, over B times B times B times C times C times C times C times B times B, then C to the fourth, C times C times C times C, over 3 times 3 times 3, then A times A times A for A cubed. Then after that, we will cancel common. So for 3, we have 3. We have also 3 here. We have 3. We have also 3. Then A, we have A. We have A. We have A. We have A. Then for B, we have B. We have B. Then B also here, here, here. Okay, for C, we cancel out all. There are 4. Here also is 4. Cancel out. Okay. What is left is... So, all of these are 1. So, when you multiply 1, how many times here? The answer is 1. Then here, what is left is 3 and A. So, the answer is 1 over A. 3A. Sorry, we have 3. Now, okay. So, as you can see, when the exponent becomes larger of a variable, the more variable you will write. The more variable you will write. So, another way of solving that without writing the factor of the variable, we will use this method so that it is easier for you to factor out those numbers. Okay, just write the factor of the coefficient, numeral coefficient, then times A squared and B over B cubed C to the fourth times B squared C to the fourth over 3 times 3 times 3 times E cubed. Okay, this is how. First, we are going to cancel out common, this one and this one. Then next is, for A, we have A squared and A cubed. So we cancel out this one, and then this one, the remaining is A. For this one, B, cancelled out, the remaining is B squared. For B2, we have B squared here. The remaining is B2, so we cancel also this one. Then C4, that one, and that one. So what is left is, for the numerator is only 1. Then over, we have 3, no? 3 and A. So the same, no? 3A. So that is shortcut way, no? For me, this is the shortcut way because, as I said, when the exponent of the variable becomes larger, it is hard for us to write the factor of the variable. Okay, next. Okay, so in this case, we will apply our knowledge in factoring. Okay, look at the numerator. So we will factor this one before we multiply this algebraic expression. So for the numerator here, what factoring method can we use? Is it common monomial factoring? Is it square of binomial? Is it perfect square trinomial, sum and difference, or what else? So for me, as I look at this, the method that can we apply for that is the common monomial factoring. So as you can see, the common is x. So we'll write x outside as our GCF, and we will divide this one by x. So x squared divided by x, that is x. Then xy divided by x, that is y. Okay, what is the sign? You copy that sign over this one. As you can see, this is a squared or binomial. So once this is squared or binomial, you just make two parentheses. Then you write the square of the first and distribute, and the square of the second, y and y. Okay, you copy the sign, then opposite to the sign, then multiplied by x plus y over same, no? Common monomial factor. So x times x minus y. Okay, after that, you apply cancellation method. You will cancel the common. So for here, this is the same, and this one, and this one. So the answer is 1. The answer is 1 over x minus y. Okay, correct. Next, number 7. Okay, the given here is 4x plus 12 over x squared minus 9 times x squared plus 2x plus 1 over x squared minus 1. So before multiplying this one, as I said, you have to factor it out first. Okay, for the first term, we have 4x, so 4x plus 12. So what method can we use for that? That is common monomial factoring. So that let us see the numeral coefficient 4 and 12. What is common there? That is 4. Then divided this expression by 4. So 4 is divided by 4, that is x. Then 12 divided by 4, that is 3, positive 3. Over this one, this is squared or binomial. So simply, you just write two parentheses and distribute the x. Then 3, 3. Then copy the sign here, and here is opposite. Then multiply this one. What kind of factoring method can we use? So we will test this one if it is a perfect square trinomial by multiplying this one by this one, by the numeral coefficient of this one. So 1 times 1 is 1, and twice times 2. 2x, so this is a perfect square trinomial. So once it is perfect square trinomial, we will just write x, two parentheses, then distribute the x. then positive 1, then positive 1. Remember that these two quantities is the same as x plus 1 squared. So, parehara na siya. They are the same. So, over, how is 1? So, same, squared of binomial. So, this is x minus 1, then x plus 1. Okay, we'll cancel now. Okay, what are the same? What are common? This one and this one. This one and this one. So what else? There's none. So we will write down our answer. This 4 dian x plus 1 over x minus 3, then x minus 1. So this is now your answer for that given expression. Okay, so in multiplication of the rational algebraic expression, this is very important for us to know the rules of exponent, the law of exponent, and our knowledge in factoring polynomials. Because if you don't know how to factor, it is hard for you to solve for to multiply algebraic expression. So if you have time to research, kindly please view my other videos regarding factorization. So for now, thank you for viewing my video regarding multiplication of rational algebraic expression, and please don't forget to subscribe my channel, Honsky Kabsky, and may God bless us all. Thank you.
Good day. Today we're going to talk about division of rational algebraic expression. The division of rational algebraic expression also needs a prior knowledge of the law of exponents and factoring, just like the multiplication of rational algebraic expression. Okay, I have here number 1 example, 12 over 20 divided by 9 over 15. So in the division of fraction, the law is to find the reciprocal of the divisor, that is the and then proceed to multiplication. Okay, so first we will rewrite the numerator, which is 12 and 20, then times 15 over 9. Then supposedly we're going to multiply automatically this one, but to be easier we have to apply the cancellation method. We are going to factor first, then cancel. Okay, what is the factor of 12? That is 2 times 2 times 3. For 20, that is 2 times 2 times 5. Then times, for 15, that is 3 times 5. For 9, that is 3 times 3. Okay, so this will be cancelled out, and this one, and this one. Also this one, and this one, this one, and this one, this one, and this one. Okay, so 1 times 1 times 1 times 1 and times 1, that is equals to 1. Then 1 times 1 times 1 times 1 times 1, that is 1, or our answer is 1. Okay, this is the answer for example number 1. Okay, number 2. For number 2, we have 6ab squared over 4CD. Then, so I remind you that the law of the fraction in dividing fraction, we have to find the inverse of the divisor, then proceed to multiplication. So this will become multiplication. So 8bc over 2 and 9a squared over b squared is the reciprocal of our divisor. Okay, next we're going to find the factor of 6. The factor of 6 is ab squared over 2 times 2cd and times 2 times 2 times 2 times d times c squared over 3 times 3 times a squared times b squared. Okay, next is we will apply the cancellation method. Okay, first we have 2 and 2, then 2 and 2, then what else? Okay, we forgot to write the factor of 6 is 3 times 2. Okay, this is 3 and this one. Okay, then next is the variable a and a squared. So when you cancel a and e squared, so it means that you are subtracting the exponent. So when you subtract a with a squared, the remaining is a. Then we have b squared in b squared. For d, we have d here, and also we have d in the denominator, and c for c squared. So what is left is c. Is there any other? Okay, nothing. So we will write the remaining uncancelled numbers and variables. So in the numerator, we have 2 times 2 times c. For the denominator, we have 3 and a. So 3 and a. So 2 times 2 times 3 c is 4c. For 3 times a, that is 3a. So this is the answer. Okay, next, number 3 example. So for number 3 is different, no? As you can see, as you observe that our example number 1 is different from number 2, and for number 2 is different from number 3. As you can see that number 3 is different. So what we can do with this number 3 is to find what method of factorization can be used in each of these expression. Okay, first we have to apply the law of fraction here, which is when you divide, you have to find the invert, or the you're going to invert this divisor, then proceed to multiplication. So we'll write 6y minus 30 over y squared plus 2y plus 1. This will become multiplication, then invert the divisor, y squared plus y over 3y minus 15. Okay, next is we will factor each of these. So for the numerator of the first term, we have 6y minus 30. What factoring method can we use for this? That is common monomial factoring. So what is common, or the GCF of these two? That is 6. So if the GCF is 6, so we will use this one as divisor. 6y divided by 6, that is y. Negative 30 divided by 6, that is negative 5. For the denominator, we have y squared plus 2y plus 1. Okay, what factorization method can be used for this, for trinomial? Is it a perfect square trinomial, or this can be applied for a general trinomial factoring? So if I try to recall the perfect square trinomial, we have to find out the factor of the last term. So we have 1 here. The factor of 1 is equals to 1 times 1. Then, according to the procedure, that we have to multiply the product of this to determine if the middle term is equals to the product of this factor, twice of the product of this factor. So when you multiply 1 times 1, that is equals to 1, then square, make it twice, so that is 2. So this is equals to the middle term. So I mean to say, this is a perfect square. So now, if that is a perfect square, we will just only make 2 parentheses, then distribute the square root of y squared, which is y and y. Then the sign is positive. Then the factor of 1, which is 1 and 1. Okay, times. How about this one? What kind of factoring method? That is the same common monomial factoring. So what is the common here? That is y. If the common is y, when we divide y squared by y, what is left? That is y. Then copy the sign. Then y divided by y, that is 1. Then over 3y minus 15. So the same method of factoring, that is common monomial factoring. So what is common here? Say 3. If 3 is common, we divide 3y divided by 3. The answer is y. Then copy the sign. 15 divided by 3, that is 5. Okay. After that, we proceed to cancellation. So, okay, the first one is this one, and this one. Then this one and this one. Okay, what else? Okay, 6 and 3. Okay, what is common? What number that can we use to divide both 3 and 6? That is 3. Okay, if it is 3, 3 divided by 3, that is 1. If we divide 6 by 3, that is 2. Okay, we will copy the remaining 2, then times y, then in the denominator we have only this one, so all over y plus 1, or the result is 2y over y plus 1. Okay, this is the answer. Okay, number 4. Okay, number 4. Okay, we will rewrite first now before we decide what factor method is used. Okay, x squared minus 9 over 3x squared plus 12. From division, we proceed to multiplication, then find the reciprocal of the divisor. So this is 2 squared plus 4 all over x plus 3. Okay, so here, what method can we use? That is the difference of 2 squares, diba? This is, we can square this one and also with this one. Okay, we will form 2 parentheses. Okay, the square root of x is x, so x here, also with here. Then the sign negative, and here is opposite. The square root of 9 is 3, then over this one, 3x squared plus 12. What method of factoring can we use? We can we can use the common monomial factoring. Okay, what is common there? Okay, so we can use 3 as the divisor, or the 3 number can be used as divisor of 12 and 3. So we will use 3 as the GCF, then 3x squared divided by 3, that is x squared, then copy the sign, then 12 divided by 3, that is 4, then this one times ano pa ba? So here x squared plus 4, we cannot factor this one, so we will rewrite 2 and 4 all over this one. So also here we cannot factor this one, x plus 3. Okay, we can cancel now. Okay, this one 1, this one also, and also with this one and this one. Okay, that's all. So we will write the remaining, which is x minus 3 over 3. Okay, that's it. The answer is x minus 3 over 3. Okay, number 4. So here, the same procedure, we will rewrite first 5x minus 14 over 18x squared times the reciprocal of the divisor, minus 12x12 all over x squared minus 49. Then proceed to factorization. So for this, we can apply the general trinomial, general trinomial. So when you answer this one, you have to square this one and square this one, you square this one, then find the factor of 14. The factor of 14 is 2 and 7. So when you add this 2 and 7, it should be equals to this the center or the middle term. So if you add this one, that is 9. So it is not equal to the middle term. So all you have to do is to change the sign either of these two. Okay, let's say negative 2 and positive 7. So negative 2 plus 7, that is 5. So that is equals to the middle term. So in that case, we will form 2 parentheses. So we will distribute the square root of x squared. This x, then copy the sign. Okay, the sign. Here we have 7. Then we have negative 2. Okay, that is the factor of this numerator. How about this one? Okay, we cannot factor this one. This is the one. This is the we cannot factor this one. So we proceed to here. So we only write this one here. Then times. Then after factor of this one. So we can use the common monomial factoring. So what number can we use with 6 as their divisor, or number that can divide both of this number, 6 and 12? That is 6. How about the variable? So we will select the smallest exponent, which is this one. So we will write x squared, then open parenthesis, we will divide 6x cubed divided by 6x squared, that is x, then 12x squared divided by 6 squared, that is 2. Okay, the sign is negative. Okay, for the denominator, this one, this is the difference of two square, diba? We can square this one also with this one. This is x, this is the square of x squared is x, the square of 49 is 7. So that is a difference of two squares. So we will write two parentheses. The first one is x, the second is also x, then copy the sign. Here is opposite, then the square of 49, which is 7. Okay, after that we proceed to cancellation. So we can cancel this out, and also here. Then what else? This one, diba? By 6. Okay, 6 divided by 6, that is 1. 6 divided by 18 divided by 6, that is 3. Okay, this one cancelled out. Cancel. So what is left is x minus 2 and x minus 2 all over 3, then this one times x minus 7, or that is 1 minus 2, x minus 2 square over 3x minus 7. So this is the answer. Okay, that is how we're going to apply the factoring method in the division of rational algebraic expression.
Today we're going to talk about adding and subtracting similar rational algebraic expression. In doing this is just like adding and subtracting similar rational numbers, in which we're going to copy the common denominator, then add the numerator. Okay, I have here example number 1. So for this example, as I said, you just copy the denominator. Okay, that is x minus 5, then combine the numerator or add the numerator. This is equals to 10 over x minus 5. So that's the answer. The next is this one. The same, no? You just copy the common denominator, then combine the numerator. Then x minus 2 is equals to 2x minus 4 over x minus 1. Okay, that's the answer. Okay, next, this one. Number 3. For number 3, the same, no? Because they are the same denominator. You just copy the common denominator, then combine the numerator. X squared minus 2x minus 7 plus 3x plus 1. Okay, then next is combine all like terms. That is x squared, then negative 2x plus 3x, that is positive x. Then this one negative 7 and positive 1, that is negative 6. All over x squared minus 9. So as you can see, this is not the final answer. We're going to find first what are the factor of this numerator and denominator. For our numerator, as you can see, this is trinomial. But you notice that the numerical coefficient of the first term is 1. So we will use the procedure where a is equals to 1. So we'll focus on this one. So our last term is negative 6. If it is negative 6, what is the factor? That is negative 2, and 3. So if we're going to add negative 2 and positive 3, that is 1, which is equals to the middle term. Okay, from that, since it is under that one, a equals to 1, meaning you just write 2 parentheses. Then distribute the square root of the first term, x squared, x, then x. Then we will use this one, minus 2, negative 2, and positive 3. All over the factor of this one. What is the factor of this one? What method? That is the difference of 2 squared, because we can square this one and this one. Okay. We will form 2 parentheses. So what is the square root of x squared? That is x, distribute. Then the sign here is opposite sign. The square root of 9 is 3. Square root of 9 is 3. So after that, you cancel out common expression. Here we have this and this. So the remaining is x minus 2 over x minus 3. This is the answer now. Okay, for number 4, we have this one, no? The same x minus 2 minus 1. Then combine the upper part. X squared plus 3x plus 2 plus x squared minus 2x minus 3. Then combine this x squared plus x squared is 2x squared. And then 3x minus 2x, that is positive x. Then 2, positive 2, then negative 3, that is negative 1. All over x squared minus 1. So after that, we're going to factor this one. Okay. What is the factor of this one? So as you can see, this can be factored using trinomial, where a is greater than 1. So we will multiply this one. This is 2 times negative 1, that is negative times negative 1, that is negative 2. The factor of this is 2 and negative 1. Okay, we will use this one as in the place of x, positive x. So we will write 2x squared plus 2x minus x minus 1. Then solve it by grouping. So what is the common factor of this? 2. Then for the variable is x. So 2x squared divided by 2 is, that is x is 1 plus 1. For this one, the quotient of this one should be equals to this one. So what number that could be divided by this number in order to get this product or this quotient? That is negative 1. So negative x divided by negative 1, that is x. 1 divided by negative 1, that is positive 1. Then after that one, take out the common. This x plus 1 and this one, 2x minus 1. So that is the factor. That is the factor of this numerator. Okay, numerator. Then x copy plus 1 times 2x minus 1 all over the factor of this one. So as you can see, this is can be factored using the difference of 2 square. So we just write 2 parentheses. Then square root of x squared is x. Then square root of 1 is negative 1. Then here opposite, positive 1. Then after that, cancel out common. So what are common here? The common is this one and this one. And the remaining is 2x minus 1 over x minus 1. So this is the answer now. Okay. Next, number 5. For number 5 is different from previous because the operation is subtraction. Before is addition. So now we are going to be subtraction operation. So the same procedure, you copy the denominator 4x minus 1, then subtract the numerator. So the answer is 2 over 4x minus 1. That's the answer. Okay, next, number 6. So we'll just write the common denominator x squared plus 2x plus 1. Then we will combine, not combine, subtract the numerator. So this is x squared plus 3x plus 1 plus 2. Okay, before I subtract that one, I will simplify this part here. So that is minus 3x plus 3. So that will become x squared plus 3x plus 2 x times negative times positive 3x, that is negative 3x, then negative times positive 3, that is negative 3, all over x squared plus 3x plus 2, sorry, the denominator, okay, that is x squared plus 2x plus 1. Okay, after that, you combine like terms. So x squared, do we have x squared here? Nothing, so we'll just write x squared. Then 3x and 3x is cancelled out because they are the same but opposite sides, so subtract. Then for this one, 2 minus 2, positive 2 and negative 3, that is negative 1, all over x squared plus 2x plus 1. Okay, then after, we will factor this out. For numerator, this is difference of two squares, so we'll just write 2 parentheses. This x minus 1, then x plus 1. For our denominator, we have this one. So this is, we can solve this using the trinomial factoring with a equals to 1. So we'll just write 2 parentheses. Okay, x, then distribute x, also x, then 1 plus 1, then plus 1. Why this is doing so? Because when we find the square root of this one is this one, and this one, the square root of 1 is 1 times 1, so minus siya. Okay, after that, cancel out common terms, this one and this one. So the remaining is x minus 1 over x plus 1. So this is the answer. Okay. Okay, this one, the common here is, the first move is to, the given, for number 7 is somewhat tricky. Now we have to solve this one by copying the denominator first, which is 3x squared plus x minus 2. Then combine or simplify first the numerator x squared plus 5x minus 20 minus negative 10, negative 6x, negative 5 squared. Okay, next is simplify the numerator x squared plus 5x minus 20 negative times negative 10, that is positive 10. Then this one positive 6x. Then this one negative and negative 5x squared is positive 5x squared all over 3x squared plus x minus 2. Then after that, combine all like terms. That is 6x squared. For this one, 5x and 6x, that is positive 11x. Negative 20 and positive 10, that is negative 10. All over 3x squared plus x minus 2. Okay. Next, we're going to find the factor of our numerator. So we will just multiply this one and this one. That is negative 60. The factor of negative 60 are negative 2 times 30, negative 3 times 20, and negative 4 times 15. So if we're going to add this one, this is equals to 11. So this is the factor which is equals to this one. So we'll use that one to factor this out. So right here as we go after. Okay, that is 6x squared plus 15x minus 4x minus 10. Then combine. Then what is the factor of 6 and 3? That is 3. For variable is x. So 6x squared divided by 3x, that is x, 2x. Then this one 15x divided by 3x, that is positive 5. For here, that is 2. So 4x divided by 2, that is 2x. This one, then divided by negative 2, that is negative 5. So we will write the common 2x plus 5 quantity 3x minus 2. So that is now our factor for our numerator. 2x plus 5 quantity 3x minus 2 all over the factor of the denominator. For the denominator, we have this one. We can multiply this one. We can factor this one using trinomial, no? Trinomial factoring. So we multiply this one. 3 times 2, that is negative 6. So negative 6, the factor is 2. The factor is 2 and 3. So we will make negative for 2 in order to get the middle term. Okay. So we will write the denominator 3x squared, then positive 3x and negative 2x, then negative 2. They combine group. So what is the common factor of this one? Is 3 for the numeric, then x for the variable. Okay, 3x squared divided by 3x, that is x. Then 3x divided by 3x is positive 1. For this, that is negative 2. Negative 2 is divided by negative 2, that is x. For negative 2 divided by negative 2, that is positive 1. So this is x plus 1. Then 3x minus 2. So we'll write this here. Plus 1. Then 3x minus 2. So cancel out common. So the answer is 2x plus 5 over x plus 1. This is the answer. Okay. So as you can see, the difference between adding similar rational algebraic expression and the subtraction of similar rational algebraic expression. So as you can see that our example is having a different level. So if you have time to review this video in order to master this process, you can do it. It's up to you. What I am here doing is just showing you what is the process of doing this, this operation. So I hope that this video would help you a lot in your mathematics subjects. And for now, thank you for watching my video and wait for my next video regarding adding, subtracting rational, the similar rational algebraic expression. So as you can see, this is a similar rational algebraic expression. But for the next video, it is all about the similar, adding and subtracting the similar rational algebraic expression. Okay, by now, goodbye and take good care. God bless us all. See you next time. Thank you. Hello, good day. Today we're going to talk about linear functions. Linear function is defined by f of x equals to mx plus b, where m and b are real numbers. M stands for slope and b stands for y-intercept. Its graph is aligned with slope m and y-intercept b. And these are the conditions that a function can be considered as linear function. First is, if m does not equals to 0, then the degree of the function is 1. If m is equals to 0 and our b does not equals to 0, then the degree of the function is 0. If m or our slope is equals to 0 and b, our y-intercept, is equals to 0, then the degree of the function is not defined. Okay, we have here a linear function. Okay, this one is what we call the function name. And then that one, our x, this one is our input. And this one is what to output, meaning in this expression we're going to find our output. Okay, if we're going to read this function, it is f of x equals to 5x plus 2. That is how to read for a linear function. Again, f of x is equals to 5x plus 2. Okay, that is how to read the linear function. Okay, example number 1. Okay, f of x is equals to 2x plus 3. Okay, is the function a linear function? Can you consider this one as linear function? The answer is yes. Why? It's because it has a highest exponent of 1. And it is also written in the form of f of x equals to mx plus b. Okay, if it is a function, what is the slope or our m in the given function? So you must look at this one. Okay, our slope m is 2. Okay, from that linear function, what is our y-intercept? Our b. So you will look at this portion here. That is, our y-intercept is 3. Okay. So, if from that given, that is our slope, then that one is our y-intercept. So, I mean to say that when you encounter a linear expression or linear function, you have to always consider that the numerical coefficient is the slope and the last term is our y-intercept. Okay. Second example, g of x equals to minus x. So as you can see, the name of our function is g. So any variable, any letter can be used as the name of your function. Okay. So is that a function? Is the function a linear function? Okay. It is yes. Because the given function has a degree of 1 and can be written as g of x equals to negative 1x plus 0. Meaning to say that the slope of the given function is 1 and the y-intercept is 0. Okay. So take note, take note. If you encounter a given linear function look like this, it is still a function. Okay, example number 3. H of x is equals to x squared plus 5x plus 4. Is the function a linear function? The answer is no. Why? Because the given function has a degree of 2. This one. Okay. So let's try this one. Determine whether h is a linear function or not. Check yes if it is a linear function and no if it is not. Write the degree of the function. For linear function, identify the slope and the y-intercept. So as you can see in our heading, these are the given function, the degree. This one depends on your answer. If it is yes or no, then this m stands for the slope. No, once you encounter the letter m in function, that means that is our slope, and this b refers to y-intercept, because as we go along with the linear function, we will encounter or we will use the letter m or the variable m and b, which is referring to slopes and y-intercept respectively. Okay, for number 1, the given is f of x equals to 3x plus 1. It is a function or not? No. Not yet, no? The first question is what degree? No, what degree? Before we decide if it is a function or not. Okay? So, the given is 3x plus 1. So, as you can see, that x has an exponent of 1. So, meaning to say, the degree is only 1. If it has a degree of 1, meaning it is a function. If it is a function, what is the slope? So, when I said slope, you are referring to this figure. So, that is 3. What is the y-intercept? So, you have to look at this one. That is 1. The next function. the function is f of x equals to negative 2x minus 8. Okay, so what is the degree? So as I said, this is for x is 1. So I mean to say this is the degree is 1. If the degree is 1, then that is a function. Okay, what is now our slope? So you look at this one. That is negative 2. What is our y-intercept? This one. That is negative 8. Okay. For number 3, f of x is equals to 7x. What is the degree? 1. Okay, because the exponent of the given variable is has an exponent of 1. And then, it is a function or not? Yes, it is a function. Now, if it is a function, what is your slope? Your m. The slope is, that is 7. You must look at this number. Okay. Now, what is our slope? As you can see, it is not written look like this. But you can rewrite that one by like this. F of x equals to 7x plus 0. Okay, you can rewrite that one like this. So I mean to say that our y-intercept is 0. Okay, next. F of x equals to negative 4 times quantity x squared minus 5. X squared. This is x squared. Okay. What is the degree? The degree is 2. So meaning to say, this is not a function. This is not a function. How about this one? F of x is equals to quantity x minus 3. So if we're going to simplify this one, that is equals to 6x minus 3. Okay. So if that, in that case, the degree of our function is still 1. Then it is a function. Then what is our slope? Our slope is 6. This is referring to this one. No, this is 18. Sorry, this is 18. Okay, when you multiply 6 times 3, that is negative 18. Negative 18. Okay, so I mean to say our slope now is negative 18. Now, next, the second to the last, f of x is equals to 10x squared plus 7x. What's the degree? The degree is the highest, no? So when you find the degree of a certain expression, you have to look at the highest exponent of a variable. So for this, the degree is 2. So if the degree is 2, that is not a function. Linear function. Remember that a linear function is having a highest exponent of 1. And it is written in the form of f of x equals to mx plus b. Okay. Then the last number is f of x equals to 3x squared minus 5x plus 1. Still, this is not a function, a linear function. Okay? Okay, I hope you understand how to identify whether a function, given function is a linear function or not. Okay, next. How to evaluate function given the value of x. For example, here, we have a function, this one, f of x equals to 2x minus 1. So how to do it? To evaluate, no? If x equals to 3, negative 3, then our f of x, our function, would be like this. So instead of writing x, you will write the value of x, which is negative 3. Then substitute 2 times negative 3 minus 1. So if quantity 3 is equals to 2 times negative 3, that is negative 6 minus 1. Then at x equals to 3, the value now of our function is negative 7. Negative 7. So that is at x equals to negative 3. Okay. How about this one? When x equals to 0, what is the value of our function now? So that is 2, by substitution, the value of x is 0 times 0 minus 1. Okay, this is 0 minus 1. So the value of our function now at x equals to 0 is negative 1. Negative 1. Then, when x equals to 2, then our function would be our function f at 2 will be equals to 2 times 2, which is the value of our x, then minus 1. So this is equals to 4 minus 1. So the value of our function at x equals to 3 is equals to 2. Equals to 2. Equals to 2. Then that is equal. The function when x equals to 2, that is 3. This is the answer. So after that, so this is how to evaluate the function using the given expression. If we're going to plot this one in a table of values, it will be look like this. So as you can see that when x equals to negative 3, our f of x is equals to negative 7. If our x is equals to 0, our function is equals to negative 1. Then, if x is equals to 2, then our function is equals to 3. Okay. So, this table of values is presented in horizontal way. But we can still use in this way, vertical presentation. So, in that case, our axis is our domain, and this f of x values is our range. Okay, remember that f of x is just the same as your y. Take note of that. Once you encounter f of x, it's just the same story with y. Okay. So if we're going to plot that one in a graph, let's say the first one, when the value of x is negative 3, in this portion, when the value of x is negative 3, the value of our f of x or our y is negative 7. Negative 7. This one. If the value of x is 0, so this point, then the value of y is negative 1. So here it is. Okay. When the value of y is 2, value of x is 2, the value of y or our f of x is 3. So there. Okay. So how are we going to write the ordered pair? For this one, this point is our coordinate of 3 and 7. Meaning to say, this point is the value of x there is negative 3 and your y is negative 7. And here, the value of our x is 0 and the value of our y is negative 1. For here, the value of x is 2 and the value of y is 3. So when we connect that one, that is now our graph of the function of the given function. Of the given function. F of x equals to 2x minus 1. Okay. Is it minus 1? Let us see. To be sure. Okay, minus 1. Minus 1. So, this is the graph of a function f of x minus 2x minus 1. For more video about this one, you can visit my channel Ronsky Kabsky for more videos for you to learn. For this time, thank you for viewing my channel. Good luck, God bless, and good day. Keep safe. Good day. For today's lesson, it is about relations and functions. Relations is a role that relates values from a set of values called domain to a second set of values called trace, or it is a set of ordered pair. Ordered pair is the pair of elements that occur in a particular order and are enclosed in brackets. Or any two numbers separated by a comma enclosed by a parenthesis. That is what we call ordered pair. It is a set of ordered pair. Now, then, the first element, which are 2, negative 1, 4, 9, and 0, are what we call the domain. The domain is the set of all x values in the relation. The same set of ordered pair, the second elements, which are 3, 5, 2, 9, and negative 6, are what we call the range. The range is the set of all y values in the relation. Okay. What makes a relation a function? So, a function is a process or a relation that associates its elements of x of a set of x is the domain of the function to a single element y of another set y is the range of the function. Or in other words, in every x values must associated to only one y values. Okay, we have 4 ways to represent function. Number 1, table of values, ordered pair, mapping diagram, and graph. So let us first talk about table of values. So I have here 3 table of values. How do we know that this table of values represent a function? So this is how. First, you have to look at the values of x and the value of y. Then after that, look at the value of x if there are repetition of numbers. If none, then that is a function. If there is a repetition of x values, then that is not a function. For this number 1, our x values are 1, 3, 4, 5, and 6. Associated to the value of y is 0, 3, 5, 7, and 9, in which there is no repetition of the x values, meaning to say this is a function. For number 2, the value of x are 6, 6, 9, 11, 13. These are associated to the value of y 0, 3, 0, 7, and 9. So as you can see that there are numbers, or there is a number repeated in the x values. So I mean to say this is not a function. For number 3, we have the value of x 1, 3, 4, 5, and 6 associated to the y value 1, 5, 8, 12, and 15. It is a function. Another way of representation in function is ordered pair. Okay, the ordered pair is something like this. The set of ordered pair named F, the set F containing these elements, which are this one. So as you can see that the value of x, which are 1, 2, 3, and 4, are not repeated. So this is a function. For the G set, we have 1, 2, 3, 3. There are 2 numbers are repeated. So you can say this is not a function. For H, we have 1, 3, 5, and so on and so forth. So this is a function because there is no repetition of the value of x. Okay, the next is mapping diagram. In mapping diagram, we have the set of domain is consisting the value of x and the set of the range containing the value of y's. Okay, how to determine that the diagram shown is a function or not? So we have to consider this condition. First is must use all the x values. You see, all the values of our domain are used in association with the values of y. Then second is the x value can only be assigned to one y value only. So I mean to say that each of this value is associated to only one value in the range. So as you can see, our 1 is for 6, 2 is to 2, 3 is to 4, 4 is to 8, and 5 is to 1. So all we can say that this is associated, the value of the domain, or each value of our domain is associated to each value of our range. So we need to say this is a function. Okay, let's take this one example. Okay, as you can see, the first, this is our domain, this is our range, our input and our output. 9 is associated to 3 and negative 3. 4 is associated to 2 and negative 2, and 1 is associated to 1 and negative 1, and 0 is associated to 0. So this is not a function. Why? Because as you can see, 9 is associated to one or more values of y. This is what we call one-to-many correspondence. This is not a function. Then mapping diagram. See, next example for mapping diagram is this one. So let us inspect. A is associated to 8, B is associated to 5, C is for 8, D is to 10. For B, there is no question. B is associated to only one value of Y, and for D is also associated to one value of Y. But for A and C, they are associated to one value of Y. So what can you say about this? Is it a function or not function? It is a function. It is a function. Why? Because this association is referring to many to one correspondence. Okay, the last one. Okay, as you can see, it is clearly the domain values is associated to only one value of Y or our range. So it is clearly it is an example of a function, and this is referring to a one-to-one correspondence. If it is a one-to-one correspondence, then it is clearly a function example. Okay, the last representation of function is a graph. Okay, here is a graph. How do we know that this is a function or not? So in the determination whether a graph is a function or not, we need to use the vertical line test. A vertical line test is a visual way to determine if a curve is a graph or a function or not. If all the vertical lines intersect a curve at most once, then the curve represents a function. Okay, I have here a vertical line test. If I move it forward, let us see how many times the vertical test curve touches our graph. Okay, from there it is once. If I move forward, still touches one. So this is a function. Next graph. If I move the vertical line test, there it only touches once. If I move it forward, still it touches once. So this is an example of a function graph. Then the last one. If I move forward this vertical line test, it touches the curve twice. These points and this point. If I move it forward, still it touches 2 points of the curve, meaning to say this is not a function. So that's all. I hope you understand that how to identify whether a certain representation is a function or not from the table of values, ordered pair, graphing, and mapping diagram. So for now, I will say thank you for viewing my video, and I hope this would help you to understand what relation and function is all about. Thank you, good day, and God bless. Keep safe. Good day. Today we're going to talk about linear equation in two variables. The linear equation in two variables is an equation that can be written in the form of ax plus by equals to c, where a plus b, a and b and c are real numbers, provided that a should not equals to 0 and b should not equals to 0 also. Remember this. In linear equation with two variables, there are two variables that can be found in that equation with a degree of 1. For example, 2x plus 4y equals to 12. So, there are two variables there which are x and y. So, meaning to say that this equation is a linear equation in two variables because each of these two variables is having a degree of 1. This one. So that is an example of linear equation in two variables. In linear equation in two variables, there are two forms. Number one is standard form. The standard formula is ax plus by equals to c. Then the second one is the standard the slope-intercept form, in which the formula is y equals to mx plus b. Okay, we'll try that one. No, the standard form ax plus by equals to c. The letters there attached to its term is e, y, and c. The e and y is what we call the coefficient of the equation, while the c is the constant of the equation. Okay, let's try this one problem. Find the slope and y-intercept of the equation 3x plus 2y equals to 6. Okay. So, to find for the slope and y-intercept, you have to convert this one to y-intercept form because this one was written in standard form. So, what is the first step in converting this one to slope-intercept form? So, first you have to write the given. This is the given. Then, the next is you will apply the property of equality, addition property of equality. How to apply that one? Property of addition property of equality. That means that if your target is this one, you have to eliminate all the other factor or all the other terms in which in this area is not having a y variable. So all the rest will be put on the right side of the equal sign. So your boundary is the equal sign. The equal sign. All the y's must be put on the left side, and all the rest must be put at the right side. Okay. So what are we going to do? So we have to apply this property. So we have that one 3x. We will copy that one plus 2y, then plus the opposite of 3x, which is negative 3x. Then also here, no, 6, then positive, then negative 3x. Remember, what you add here also will be added in the other side. Then after that one, you simplify. How to simplify? So, you copy this one, 3x plus 2y, then this one. We multiply this one, positive to negative 3x. The answer is negative 3x. Also with this. So, in this case, you write first a number with a variable. So positive times negative 3x, that is negative 3x, then positive 6. Then after that one, this one, positive 3x and negative 3x is cancelled out because they have the same but opposite sign. So what is the remaining is only 2y equals to negative 3x plus 6. So our simplification is just this part, this one. Then our answer would be, we will apply, and the next step is to apply the multiplication property of equality to eliminate this one. We will apply the multiplication property of equality. So how are we going to do that? So first, you have to find the inverse of 2. The inverse of 2 is 1/2. So 2 times y. So what you multiplied here should also be multiplied on the right side. And times negative 3 plus 6. So 2, this is cancelled out. Diba? So that cancelled out. Then what is left is y. Then this one, positive 1/2 times negative 3x. That is 1/2, 3 halves, negative 3 halves x. Plus this one, 1/2 times 6, that is 3. So this is now your simplified form for your answer to that question. Hindi pa. You have to, what we did is just converting this one to the slope intercept form. So the problem asking for the slope and the y-intercept. So multiplication, this is the one, this is what we write here. Then the result from simplification is this one. Okay, so the question is asking for the slope. So our slope there is 3 halves. Then our y-intercept is 3. This one. Okay. Okay, take note of our answer. Our y-intercept form for this standard form is y equals to negative 3 half x plus 3. Okay, now we will do a reverse. Our given is the slope intercept form, then back to the standard form. So we will need to have this answer in our process to determine the result from y-intercept form, from the slope-intercept form to the standard form. Okay, so this one. Okay, this is the result of our previous, this one. So we will do it back, or return it to the standard form. So we will write first the given, this one. Then after that, we will apply the multiplication property of equality. So how it does? So we know that this is our denominator. So in order to eliminate this one, we have to multiply both sides by 2. So 2 times y then equals to 2 times negative 3 half x plus 3. Okay. So after that is our multiplication property of equality. Then after that, we will simplify. Okay. We will simplify. This one, that is 2y. Then this one is 6 over 2, that is negative 3. Then this one is positive 6. Okay. Then after we will apply the addition property of equality, meaning we have to transfer all the all the terms with variables to the left side, just like this form of the standard form. And on the right left side, all the constant. Okay, so this is how it does. First, we write y, then equals, then this one is negative 3x plus 6, then plus, then what is the opposite? Opposite sa negative 3, that is positive 3x. So you also add here positive 3x. Then after that, you simplify. So in simplification, you have to, diba, which is first, y or x? So we have to put first the term which has an x. So 3x plus 2y equals to, this one is cancelled out. So the answer now is 6. Okay. 3y plus 2y equals to 6. Is that the same with the given in the example number 1? Okay. We will try. 3x plus 2y equals to 6. Okay, let us see. Okay, correct. Okay, so this is the summary. Here is the given. Then this is a solution from standard to slope-intercept form. And upon arriving at this result in the form of y-intercept form, we will use this here to find again the standard form. So as you can see, in this, what we did is just rewriting the equation from standard form to the slope-intercept form. Okay, did you get the idea? What we are doing here is just converting the standard form to slope-intercept form, and from slope-intercept form, we convert that one to standard form. Okay, let's take another example. Without writing this part, without writing those labels. Okay, we have this second example. 3x. So the first thing to do is to convert this one from standard to slope-intercept form. Okay, first we have to write the given 3x minus 5y equals to 10. Then after that, we will apply the addition property of equality, in which we have to transfer or transpose all the terms which has no y variable to the other side. Okay, for this, we have 3x minus 5y plus times negative 3x equals to 10 plus negative 3x. Then after that, we simplify. So we'll still just copy this one, 3x minus 5y. This is negative 3x equals to 10 negative 3x. Okay, after that, we will combine all like terms. We have here 3x, this is negative 3x, so this will be cancelled out. What is left is negative 5y. Then this one is negative 3x plus 10. I transform this one into this one because it is the standard is you have to write first the term which has a variable, then after the constant. Okay, so after that, we have to apply the multiplication property of equality to eliminate negative 5. So we will multiply both sides by negative 1/5 times negative 5y equals to negative 1/5 times 3x negative 3x plus 10. Okay, so this one is cancelled out. Cancelled. What is left is y. Then here, 1/5 negative 1/5 times negative 3x, that is positive 3/5 x. Then this one negative 2. 1/5 1 times 10 is 10 divided by 5 is 2. And so it's negative 2. So this is your simplified answer. Or this is your converted standard equation from standard into slope-intercept form. So now we will use this one to convert this slope-intercept form to standard form back to the given, which is written standard form. So first we will write the given, this y 3/5 x minus 2. Okay, next is we will eliminate this 5. So how to do it? You have to multiply both sides by 5. Then 5, then 3/5 x minus 2. Then after we will simplify 5 times y, that is 5y. This one 5 times 3/5, that is 15 divided by 5, that is 3. So the answer is 3x. 5 times negative 10 and negative 2, that is negative 10. Okay, after that we will apply the addition property of equality. So meaning we have to transpose this one to the other side. Okay, so 5y plus negative 3x as well as here minus 10 plus negative 3x. Okay, after that we will simplify. So as I said that you have to write first what is the first variable. So x is, we will write first the x, no? The term which has the x. So this is plus times negative 3x, that is negative 3x, then followed by y plus 5y equals to this one. This is cancelled out. This is cancelled out because this is positive, this is negative. So what is left is 10. Okay, so actually this is in the form of, the result is already in the form of the standard form. But the problem here is our term which has the x value is negative. So we must transform this one to positive by multiplying both sides by negative 1. So negative 1 times negative 3, that is 3x. Negative 1 plus positive 5y, that is negative 5y. Then negative 1 times negative 10, that is positive 10. So this is now your answer. So as you can see, we return to the given from standard form. From standard form going to the slope y-intercept form, then from y-intercept form going to standard form. Okay, That is how to convert the standard form equation to the slope-intercept form. Okay, let's try the last example. Our given is written in slope-intercept form. So we will convert that one to slope-intercept to standard form. Okay, first we have to write the given. Y is equals to 1/2 x plus 3. Okay, to eliminate this one, we will apply the multiplication property of equality. Okay, we multiply both sides by 2. Okay, plus 3. Okay, so this will become 2y, and this one will become, this is cancelled out, so what's left is x. And 2 times 3, that is positive 6. Then after that, since we are converting this one to the slope-intercept form, we will apply a multiplication property of this. No? We will multiply here. We will multiply it here using 1/2 to eliminate y. No. The next step is to transpose all the variable to the left side. Okay, so we'll apply the addition property of equality. So 2y plus negative x 2y plus negative x equals to x plus 6 plus negative x. So simplify. So as I said, you have to write first the x. So positive times negative x, that is negative x. Then our y plus 2y, then equals to, this is cancelled out, so that what's left is 6. So in order to make our x positive, we have to multiply this one to negative 1. This will become positive x, negative 2y equals to negative 6. So this is your standard form for this given slope-intercept form equation. Okay, so from here we will compute again back to the standard form. So we'll write first the given x minus 2y negative 2y equals to negative 6. Then after, since we're looking for the slope-intercept form, we will apply the addition property of equality. That is x minus 2y in positive negative x equals to negative 6 plus negative x. So simplify. We have, and this one cancelled out, what is left is 2y. Then this one, so we will write this first. This is negative x, then negative 6. Then after, we will eliminate this one, no, that negative 2, by multiplying both sides by negative 1/2. So negative 1/2 y equals to 1/2 negative 1/2 times negative x negative 6. Okay, so this is cancelled out. What is left is y. Then this one, negative 1/2 times negative x, that is 1/2 x. In negative 1/2 times negative 6, that is positive 3. Okay. Now, look at the result. The given is this one. And we asked to transform this one to slope-intercept form. No, standard form, because this is written in slope-intercept form. So this is our answer for the standard form. To go back to its original, we will use this one, no, this answer. Then we process it this way and we arrive this answer the same to the given. Okay, that is how to transform from standard form to slope-intercept form and vice versa. So the process is just first when you want to transform, we have to transform or rewrite the given standard the given equation in standard form. First you have to rewrite, then apply the addition property of equality. Then next you have to simplify, then apply the multiplication property of equality, then simplify. Then when you want to convert the equation which is in slope-intercept form, you have to apply. We have to write the given first. Then after that one, you apply the multiplication property of equality. Then after that, you simplify. Then after that, you apply the addition property of equality. Then after that, simplify. That's only the process of converting the slope standard form and vice versa. So I hope you learned something in this video, and thank you for viewing my video and the rest of my video. For now, I thank you. May God bless us all, and good day. Good day. Today we're going to talk about rectangular coordinate system. I have here a brief history of the rectangular coordinate system. The coordinate system we commonly use is called the Cartesian system, after the French mathematician René Descartes from 1596 up to 1650, who developed it in the late 17th century. Legend has it that Descartes, who liked to stay in bed until late, he was watching a fly on the ceiling from his bed. He wondered how to best describe the fly's location, and decided that one of the corners of the ceiling could be used as reference point. So I mean to say, from this history, it is only started from a fly's location. So let's try to use this invention. So as you can see, we have here a Cartesian plane divided by the two lines. This horizontal line is known as the x-axis, and the vertical line is what we call the y-axis. Due to this division, the quadrant was created. Now, the first area is for quadrant 1, the second is for quadrant 2, this area is quadrant 3 and quadrant 4. And this area here is our origin. Okay. So in this Cartesian plane, all the points here are made up of coordinates, and that coordinate composed of the x and y coordinates, where the x coordinate is known as the abscissa and the y coordinate is known as coordinate. Okay, to know the value of these coordinates, let us number it from the origin. The number of this for this Cartesian case that when you write the number from the origin 0 to the right is positive for x-axis. To the left of the origin are negative for x-axis. From 0 upward, all the numbers are positive for y-axis, and from this origin going down are all negative for y-axis. That's why when we locate this number at quadrant 1, all are positive numbers. So any points here, any coordinate here are all positive for x and positive for y. And for quadrant 2, all the x value here are negative, but for y are all positive. Then for quadrant 3, all the values of x and y are negative. For quadrant 4, all the values of x here are positive, then all the values of y are negative. Okay, so it is very important to know all of this, because as we go on with our topic in reticular coordinate system, we will always encounter this. Okay, I have here in the Cartesian plane different objects with corresponding points, and here I have a table and name of object. Okay, what we're going to do now is to locate those coordinates from the plane and write it here. Then the location where the quadrant, what quadrant are those objects can be found. Okay, first is the ball. The ball is located in -6 and 7. So that is -6 for x, then +7 for y. What quadrant? This is quadrant 2. Electric fan. Electric fan can be found in 6 for x, then -5 for y. 6 then -5 for y. What quadrant? Quadrant 4. Then Bible. Bible is located in -5 for x and -5 for y. -5 and -5. What quadrant? Quadrant 3. Bag is this point, +4 and +2. +4 and +2. What quadrant? 1. Tricycle is this point, -7 for x and -2 for y. -7 and -2 for y. What quadrant? 3. Table, this point, 2 and +y for +5 for y. +2, +5. That is quadrant 1. Car, this point, 2 and -3. 2 and -3. What quadrant? 4. TV. TV is located here, -4 and +3. -4 and +3. What quadrant? Quadrant 2. Okay, that is how to locate the ball. So this is the location of the ball, the coordinates where we can find the ball and the quadrant. Okay, it is very easy to locate. Okay, next. Now, from this example, we're going to plot the point of each of this coordinate. point A, B, C, D, E, F, G, and H. We're going to locate the point and write its point name. Number 1, positive 4 and 2. 4 for X, 2 for Y. So this one. Okay, this is point A, located in quadrant 1. Okay, next, negative 3 for X, then positive 3 for Y. So this one. This is point B, located in quadrant 2. 1, 1, and 2. Okay. For number 3, C, negative 7 and 5. Negative 7 and 5. So here. So this is point C, located in quadrant 2. D is negative 5 and negative 5 for Y. Negative 5, so this one. This is point D, located in quadrant 3. E, 5, positive 5 and negative 6. Positive 5 and negative 6. This is quadrant E, letter E, point E, located in quadrant 4. Then F is 7 and 4. Located, this is point F, located in quadrant 1. Then 7, point G, 2 and negative 3. 2 and negative 3, this one. This is point G, located in quadrant 4. This one, H, negative 6 and negative 5. This one. This is point H, located in quadrant 3. Okay, that's all. So as you can see, it is very simple to locate a coordinate in our Cartesian plane, and also to locate, in the previous example, to locate the object where it can be found in our coordinate system. So I hope this presentation would help you in your mathematics subject, especially the grade students who are now answering their modules. For now, I say thank you for viewing my video and expect more in connection with rectangular coordinate videos. Thank you, and goodbye. Hello, good day. Today we're going to talk about slope of a line. The slope of a line is a measure of the incline of the line. The slope is a number which indicates both the direction of the line and the steepness of the line. The slope means the steepness of a line. The bigger the slope, the bigger the steepness. The slope of a line can be computed by m equals to rise over run. This means vertical change equals to over horizontal change. Or it can be change in y coordinate over change in x coordinate. Okay, remember, the value of the slope tells the trend of the graph. Okay, I have a graph here. In the graph, usually in finding the slope of the graph, we will use this formula, rise over run. So to find for the rise, you have to count how many steps going up. That is for the rise. Say 1, 2, 3, 4, 5, 6, 7, 8. There are 8 steps or counts before turning right. If you turn right, that means that our run is positive. Okay. Let us count 1, 2, 3, 4, 5, 6, 7 steps. Okay. Our run is 7. So this is now our slope for this graph. 8 over 7. Which means that if m is greater than 0, our slope is greater than 0. This means that the graph is increasing from the left to the right. So it is uptrending, increasing. Why increasing? Because if you look at the value of x from 0 is increasing up to this point. Okay, that is about this graph. Okay, next graph. Okay, same, we are going to use this formula. This one. Okay, so as you can see that this graph is opposite to the previous graph. Okay, so let us find how many counts for the value of a rise. Okay, let's count 1, 2, 3, 4, 5, 6. Okay, the rise is equivalent to 6. Now, from that rise, we are turning left. So that means the value of our run is negative. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the value of our run is 9, negative 9, or negative 2/3. Then, if the value of our slope is negative, that means that the graph is decreasing from the left to the right if your slope is less than 0. Negative 2 over 3 or negative 2/3 is less than 0. That's why our graph is decreasing from the left to the right. Okay. Next. Again, we will use this formula for this graph. As you can see that the graph is a horizontal line. Okay, let's find what is the rise and run of this graph to know its slope. Okay, is there a rise for this graph? The rise is 0. Okay, how about the run? So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, our run is 9. So our slope now is equals to 0 over 9 or 0. Okay, if the slope is 0, then the graph is horizontal line. So I mean to say that when you encounter a graph which is a horizontal line, that means that the slope of that graph is 0. Okay. This graph. The graph is a vertical line. Okay. Let us know what is the slope of this graph. Okay. What is the rise? Let us count. 1, 2, 3, 4, 5. So the rise is 5. But the problem here, we don't have run. So 0. So I need to say that our slope is equals to 5 over 0. When you divide 5 over 0 is undefined. So I need to say that our slope is undefined. If the slope is undefined, then the graph is a vertical line. So as I said, that when you encounter a graph like this, that means that the slope of that line is undefined. Okay. The slope of the line passing through 2 points. For example, here we have P1 containing these coordinates y sub 1 and x sub 1 and y sub 1. And for the point 2, we have x sub 2 and y sub 2 is given by this formula. Slope equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Or it can be the slope is equals to y sub 1 minus y sub 2 over x sub 1 minus x sub 2, where x sub 1 should not equals to x sub 2. Why? Why is it that it should be not equal, it should not be that x1 should not equals to y1, y2, x2? Because when you subtract y sub 1 with y sub 2, when they have equal value, the answer is 0. When the denominator is 0, from this formula, the slope becomes undefined. So in this case, we have two formula here. Either of these two can be used to determine the slope. Okay. Problem number 1. Find the slope of the line passing through these 2 points. Okay, here we have 2 points. This one and this one. Let's say this is our P2. Point 2. This is our point 1. Okay. So, from this formula, if that is point 2, so this coordinates, this is our y sub 2, this is our x sub 1, x sub 2. Okay. Let us label in order to for us to. Okay, this is our y sub 2, this is our x sub 1, this is our y sub 2, y sub 1, this is our x sub 1. Okay, so as I said, any of these two can be used as point 1 or point 2. It's up to you. Okay, for this, as I labeled it, our y sub 2 is 3 minus y sub 1 negative 4 all over x sub 2, this is x sub 2, sorry, this is x sub 2, so 0 minus x sub 1 negative 2. The answer is 3, then negative times negative 4, that is positive 4, negative times negative 2, that is positive 2. So the answer is 7 over 2. So this is the slope of that graph, which means that m is greater than 0. M is greater than 0. That means that our graph is increasing from the right to the left. Okay. Okay. Next number. Okay. For this number 2, our graph is like this. Okay, let us label this one. This is our this is our P1. This is our P2. Point 2. This is our y sub 1. This is our x sub 1. This is our x sub 2. This is our y sub 2. Okay. From the formula, we will substitute to find its slope. Okay. Our y sub 2 is 1 minus y sub 1, which is 5, over y sub x sub 2, which is 6, minus is x sub 1, which is 0. So the answer is negative 4 all over 6. To reduce it to lowest term, we have negative 2 over 3. This is our slope for this graph, which means that when your m is less than 0, our answer is less than 0 because this is negative 2/3. So this means that the graph will look like a decreasing graph from the left to the right. So as you can see, this is a decreasing graph. Okay. Next problem. Okay. As you can see that our graph is a horizontal graph. Okay. Let's say this is our P1. This is our P2. Point 2. This is point 2. This is our x sub 2. This is our y sub 2. If this is point 1, this is our x sub 1. This is our y sub 1. Okay. So by substitution, we will have this one. Y sub 2 is 4. Minus y sub 1 is 4 also. X sub 2 is 7. Minus x sub 1, which is 1. So the answer is 0 over 6. Or our n is equals to 0. Okay. When m is equals to 0, that means that your graph is a horizontal graph. So when you encounter a graph look like this, then that means that graph is having a slope of 0. Okay, this one. Find the slope of this graph. Okay, let's say this is your P2. This one P2. This is P1. Okay, this is your x sub 2, y sub 2. This is your x sub 1, y sub 2, y sub 1. Okay. By substitution, we have y sub 2 negative 5, y sub 1 is 5 all over x sub 2 is negative 3 minus x sub 1, which is 6. By equals to this one, the same sign is negative 10. Also with this one over negative 9. So our m is equals to 10, positive 10 over 9. So as I said that when your slope is greater than 0, the form of your graph is increasing, or the trend of your graph is increasing. Okay. Then last one. Okay. So let's say this is your P2. This is your P1. Okay. If this is your P2, this is your x sub 2. This is your y sub 2. If this is your P1, this is your x sub 1. This is your y sub 1. Okay. By substitution, we will have y sub 2 is 4 minus negative 3 for y sub 1 all over x sub 2 negative 5 minus x sub 1, which is 2. The answer is 4 negative times negative 3, that is positive 3, all over this one negative and negative 2, that is negative 7, equals to 7 over negative 7, or your m is equals to negative 1, which means that when your m is less than 0, your graph is decreasing. The trend of your graph is decreasing. Okay, so I hope you learned something out of this topic, and thank you for watching. I hope this would help you to solve your mathematics subject, especially your module nowadays. Thank you and God bless. Hello, good day. For today's lesson is all about graphing linear equation using 2 points. Remember, in graphing linear equation, 2 points are enough to draw the graph because it is a line graph. To understand this reminder, let us start solving this equation. Okay, the first question is graph the given equation. So, we're going to graph this equation by using 2 points. To find 2 points, you must have assumed value of x. You must assume at least 2 value of x. Okay, let's set x equals to, let's say 0. Okay, let's rewrite the given. If x is 0, so 2 times 0 plus 1 plus 1, then 2 times 0, that is 0, plus 1, so the value of y is 1. So we will write that one in the table of values. Okay, if x is 0 from here, then your y is 1. Okay, another one. Let's set x equals to 2. Y is equals to 2 times the value of x, which is 2, plus 1. By simplification, we have 2 times 2, that is 4, plus 1, so your y is equals to 5. Okay, if x is 2, taken from here, then value of y is 5. Okay, let's locate this coordinate. 0, when x is 0, our y is 1, so here. When x is 2, our y is 5, here. To connect this one, to form our graph, that will be our graph for that equation. So this is the point coordinate 0 and 1, this one 2 and 5. Okay, that is the graph of the first equation. Next equation, y is equals to negative 3x plus 12. In the same procedure, we assume value of x. Set x equals to, let's say 1. Okay, y is equals to negative 3 times the value of 1 plus 2. So by simplification, this is negative 3 times 1 is negative 3 plus 2. So your y is equals to negative 1. Okay, we write that one in the table of values. So when x is 1, your y is negative 1. Okay, let us use another value of x. Let's say x is equals to 2. So y is equals to 3, negative 3 times the value of x is 2 plus 2. So this is negative 3 times 2, that is negative 6 plus 2. So your y value is equals to negative 4. So when x is 2, your y is negative 4. Okay, let us plot that number, that pair. So negative y4, y4, 1 for x, then negative 1 for y. So here, then when x is 2, negative 4 for y. Okay, connecting that one to form our graph. That will be our graph for that equation. So this point is 1 for x, negative 1 for y. This point is 2 for x, negative 4 for y. Okay, that is how to graph a given equation. Okay, number 3. The same, we have to set two values of x. You see here, let's try negative 2. If x is negative 2, then y is equals to 2 times the value of x, which is negative 2 minus 3. Then, by simplification, 2 times negative 2, that is negative 4 plus negative 3. So, your y is equals to negative 7. We'll plot that one. When y is negative 2, your y is negative 7. Okay. Let's say set x equals to 1. Okay. Y is equals to 2 when the value of x is 1 plus, negative, this is negative 3. Then, by simplification, this is 2 minus 3. So, your y is equals to negative 1. Negative 1. So, when x is 1, negative 1 is for your y. So, by plotting negative 2 and negative 7, negative 2 is what for x, then negative 7 for y. This one. This one. Then, when x is 1, negative 1 for y. So, by connecting that point, we'll have this graph. Okay. So, this point is 1 for x, negative 1 for y. This point is negative 2 for x, then negative 7 for y. Okay. That's the graph for the given y equals to 2x minus 3. Now, this next example, so as you can see in the previous example, the given is equation. But for the next example, the given are the points. So all you have to do here is to plot all of those points in the graph, then connect to form your graph. Okay, the first one is 7 for x, 1 for y. Then 2 for x, then negative 4 for y. So to connect that one, it forms now our graph of that 2 points. So this is our point coordinate for 2 and negative 4, and this one 7 and 1. Okay, next, the given is 5, 6 and negative 3 and 2. So let us locate 5, then 6. So here it is. Then negative 3, this one, and 2, this one. So for this form the graph, That's it. So this is 5 and 6, and this one is -3 and -2. Okay, that's the graph of that points. Okay, for number 3 we have -4, this one, and 0. Sorry. Then +3 and -6 here. To connect that one, that is our graph for that points. So this is our -4 point coordinate, then this one our point coordinate 3 and -6. Okay, that's the graph for number 3. Number 4, 4 and -5. So this one. Then the other one is 2, -2 and -2, this one. And connect. Okay, that is the graph. This is 4 and -5. This one is -2 and -2. Okay, last number, -3, -3 and 2. This part. Yeah. -3 and 2. This one. Then 2 and -5. 2 and -5 here. So to connect that one, that is our graph. So don't forget to write the coordinate in every point because that is your guide. Okay. Then this one is 2 and -5. Okay, that is how to graph an equation that passes through 2 points, and also graphing also the first 3 example which we solve the equation and finding 2 points for the graph. So I hope this would help you in your mathematics subject, especially the one who's doing their module. I hope this would help you. For now, thank you for viewing my video, and God bless, and take care. Keep safe. Hello, good day. Today we're going to talk about graphing linear equation using x-intercept and y-intercept. Remember, the x and y-intercepts of a line could represent 2 points which are A and 0 and 0 and B. To find the x-intercept A, set y to 0 and solve for x. To find the y-intercept B, set x to 0 and solve for y. Okay, to understand this thing, let's solve this equation. Graph the given equation y equals to 2x plus 1. So using this x and y intercept, we have to first find our y-intercept. To find the y-intercept, first we have to set our x to 0. Set x equals to 0. Then solve the equation. So if x is 0, then y equals to 2 and the value of x is 0, then plus 1. Then this is 2 times 0, this is 0 plus 1. So therefore our y is 1. So the coordinate now for this equation for the y-intercept is 0 for x, 1 for y. Then to find for the x-intercept, we will set y to 0. Using the equation, our y becomes now 0, then 2x plus 1. Okay. To apply the addition property of equality, we will write 2x plus 1 plus opposite of positive 2x is negative 2x. Also here, negative 2x. So, by simplification, this becomes 2x equals to, this will be cancelled out, and this one. So, the remaining is 1. So, applying the multiplication property of equality, we will find the inverse of 2, that is negative 1/2 times negative 2x equals to 1. So therefore, this will become, or this will be cancelled out. The remaining is x. Then this one, we have to multiply this one by 1/2. Okay, negative 1/2. So negative 1/2 times 1, that is negative 1/2. So our value when x in x-intercept, when y is equal to 0, that is negative 1/2 for x, then 0 for y. So we'll plot this one. First, we have this first 0 and 1. 0, this is the part where our graph intersect with the y-axis. Then second, negative 1/2 and 0. Negative 1/2 and 0. Negative 1/2 for x, then 0 for y. If we're going to connect that one, that will be our graph of that equation. So we will label this one. This is our coordinates 0 and 1, and this one is negative 1/2 and 0. This is our y-intercept, and this is our x-intercept. Okay, that is how to graph an equation using y-intercept and x-intercept. Okay, let's take the second equation. The second equation is 2y equals to 2x plus 4. Okay, let's find the y-intercept. To find the y-intercept, we have to set x to 0. Set x to 0. Then, by substitution, we have y equals to 2 times 0 plus 4. So the value of y now is 4. Then our coordinate is 0 for x, 4 for y. Then to find for the x-intercept, you will set y to 0. So from the given equation, y becomes 0, then 2x plus 4. Applying the addition property of equality, this will become 2x plus 4 plus opposite of 2x, that is negative 2x. Also here. So, simplifying it, that is 2x equals to, this will be cancelled out, and this one, then the remaining is 4. Applying the multiplication property of equality, we will multiply this one by its inverse. What's the inverse of 2? That is 1/2. Negative times negative 2x equals to negative 1/2 times 4. Okay, simplify. This will be cancelled out. The remaining is x. This one, negative 1/2 times 4, that is negative 2. Okay. So meaning, our coordinate for this is negative 2 for x, then 0 for y. Okay, we will plot that one in our graph. So, 0 for x, then 4 for y here. Then negative 2 for x, then 0 for y. So here. So we will label it. This is negative 2 and 0. This one is our 0, then 4. So as I said, when a point where the graph intersect the x-axis, that is our x-intercept. When the graph intersect the y-axis, then that is our x and y-intercept. So we'll draw our graph. Okay, this is now our x-intercept, and this is our y-intercept. Okay, that is how to graph this equation number 2. Okay, next. Okay, as you can see in the previous examples, all the equations are written in slope-intercept form. Now the third is written in standard form. So don't worry if it is written in this way, because we are just setting the value of x and y to 0 to find for the x-intercept and y-intercept. Okay, to find for the y-intercept, we have again to set x to 0. So using the equation, we have there 3 times 0, because our x is 0, then minus 4y equals to 12. So the remaining is negative 4y equals to 12. Negative 12. Okay. So after that, we will apply the multiplication property of equality by finding the inverse of this. No? So the inverse of 4 is 1/4, negative 1/4, times negative 4y equals to negative 1/4 times negative 12. So this will be cancelled out. The remaining is y. And then this 1/4, negative 1/4 times negative 12, that is positive 3. So here in the y-intercept, our x coordinate is 0, then our y is 3. Okay, here, the x-intercept, we will set y to 0. Okay, by substitution, we have 3x minus 4 times 0, because our y is equal to 0, then equals to negative 12. Then the remaining is 3x equals to negative 12. Then applying the multiplication property of equality, we have 1/3 times 3x equals to 1/3 times negative 12. Cancel this out, the remaining is x. 1/3 times negative 12, that is negative 4. This is the value of your x. So your ordered pair is negative 4 for x, then 0 for y. So we'll plot this one, these 2 points. The first point is 0 and 3. So this one here. Then the second one is negative 4 and 0. So we'll write the coordinate negative 4 and 0, and this one is our 0 and 3. Okay, we will draw now our graph. Okay, that's the graph of that equation. So this point is our x-intercept, and this point here is our y-intercept. Okay, next number. The next number is 2x plus 7y equals to 14. So first we have to find the y-intercept. To find for the y-intercept, we have to set x to 0. Set x to 0. So 2 times 0 plus 7y equals to 14. The remaining is 7y equals to 14. Applying the multiplication property of equality, this will become 1 over 7 times 7y equals to 1/7 times 14. So the remaining is only y, because we are cancelling it out. Then 1 over 7 times 14, that is 2. So our coordinate for this one is 0 and 2. Then for this one, for x-intercept, we will set x to 0. So y, we will set y to 0. Okay, 2x plus 7 times 0 equals to 14. What is left is 2x equals to 14. So applying the multiplication property of equality, this will become 1/2 times x equals to 1/2 times times 14. So the result is this will be cancelled out. The remaining is x. And this one is 1/2 times 14, that is 7. Okay, so our coordinate now is 7 and 0. So we plot this one. When x is 0, 2 for y. When x is 7, 0 for y. So that this is our one. Okay, before that, I would like to write first the coordinate. 2, then this one is 7 and 0. Then our graph will be like that. Okay, so this is our x-intercept, and this is our y-intercept. Okay, last one. Okay, so here we have y equals to negative 2/3 x plus 4. So the same, we are going to find the y-intercept and x-intercept to graph this equation. So to find the y-intercept, you have to set x to 0. So we will set x to 0. So y is equals to negative 2/3 times 0 plus 4. So y is equals to 0 plus 4. Y is equals to 4. So this is 0 for x, 4 for y. Okay, for x-intercept, we have we will set y to 0. Okay, using the same equation, this will become 0 equals to negative 2/3 x plus 4. Okay, applying the addition property of equality, this will become negative 2/3 x plus 4 plus the opposite of this is positive 2/3. Here is 2/3 x. Okay, by simplification, we have 2/3 x equals to, this will be cancelled out, 4. Okay, after that, we will apply the multiplication property of equality in order to eliminate this one. Okay, what is the inverse for this? That is 3/2 times 2/3 x equals to 3/2 times 4. So this will be cancelled out. That is x equals 3 times 4 is 12 divided by 2, that is 6. So the value of our x is 6. So our coordinate now is 6 for x, 0 for y. Okay, we will plot this one. 0 when x is 0, y is 4. When x is 6, 0 for y, so this one. Okay, we will label each point with their point coordinate. Okay, we will plot the graph. Okay, that's the graph of that equation. And this is now our x-intercept, and this is our y-intercept. Okay, so in graphing linear equation using the x and y-intercept, you will do finding the y-intercept and x-intercept in the given equation. In finding for the y-intercept, you have to set x equals to 0, then find for y. And to find for the x-intercept, you set y to 0, then find the x. Then after that, you graph. And the point where your graph crosses with the x, that point is what we call the x-intercept. And the point where the y-axis intersect the graph, then that is your y-intercept. Okay, that's all for today, and thank you for viewing my video. Thank you, good day again, and God bless. Okay. Good day. Today we're going to talk about graphing linear equation using slope and y-intercept. There are 4 methods of graphing linear equation. The first one is using 2 points, the second one using the x and y-intercept, and the third one is using slope and y-intercept, and the last one is using the slope and a point. So our target for now is using slope and y-intercept. There are 2 forms of linear equation. Standard form, which is ax plus by equals to c, then the slope-intercept form, which is y equals to mx plus b. So we'll focus our study here, in which that formula y equals to mx plus b, m there is our slope, then b is our y-intercept. So to solve for the slope, we must use this formula. M equals to rise over run. You can use that one in all of the problem that we have. Okay, first example is graph the given slope and y-intercept. M is equals to 4 over 5, then b equals to -4. Okay, so this b, as I said, this is our y-intercept. That is the first point we're going to plot in our Cartesian plane. So -4 can be found in the y-axis. So this is the one. Then your slope, which is equals to rise over run, your rise there is 4, then your run is 5. Okay, so that means that your rise from the point of your y-intercept, you will count 4 steps. This 1, 2, 3, 4. And after that, for the run. The question is, where are you going to turn? To the right or to the left? So many take note of this. When your slope is positive, that means that you have to turn right. If your slope is negative, you will turn left. So for this instance, our slope is positive. So we will turn right 5 steps. 1, 2, 3, 4, 5. So this is the second point. To connect that one, that will be our graph of that given. slope 4/5 and b, or our y-intercept, -4. The second one is our slope is 3 and our y-intercept is 2. So we must plot our y-intercept to this one. Then in our formula rise over run, from that our rise is 3, then our run is 1. So any number, whole number, automatic 1 is our run. Okay, we will plot that one. 3 for rise, 3 steps upward from the y-intercept. So this is 1, 2, 3. So run 1. Right, because our slope is positive. So to connect that one, that is our graph of that example. Okay, next problem. Graph the given slope and y-intercept. M is equals to -3/4 and b equals to negative. So our y-intercept is negative. So we look at the y-axis. -3 is here. Then our slope is negative. Now -3. -3. So -3. Our run there is 3. So we count 3 steps. 1, 2, 3. So since it is negative, we will turn left. 4 counts. 1, 2, 3, 4. So this is the point. Okay, we will correct that one. Okay, that is our graph of number 3 problem. Okay, the fourth one. Graph the given equation y equals to 2x plus 1. So as you can see, there is no given slope and y-intercept, but the given there is an equation which is written in slope-intercept form. So from that, we will extract our slope and our y-intercept. So our slope there is 2 or 2/1. Then our y-intercept is 1. Okay, we plot that one in our Cartesian plane. Our y-intercept or b is +1. Then our run is 2. So we'll count 2 steps. 1, 2. Then that is positive. So 1 is 1. So 1 step to the right. 1. So this is our second point. To connect that one, that will be our graph of that equation. Okay, the last one. The last one is an equation written in standard form. So we must convert that one. To slope-intercept form, which is y equals to mx plus b. Okay, so as you notice, no, dapat all the y's will be put in the left side of our equation, and all the constant and other variables will be placed in the left side. So we will retain -4y, then -8x and -12. So remember that when you transpose any terms to the other side, that will become negative. Okay, this one, to eliminate this one, you have to multiply 8 by 1/4. -4y equals to 1/4 times 8x minus 12. In here, we are applying for the multiplication property of equality. So this will be cancelled out. The remaining is y. This one, -1/4 times 8, -8x. The result is 2x. negative 12 times negative 1/4, that is positive 3. From there, we can now extract our slope. Slope is 2, then our y-intercept is 3. So we'll plot now our y-intercept, which is positive 3 here. Positive 3. So positive 3, this one. Then our rise there is 2, then run is 1. So we'll count 2 step upward. 1, 2, then 1 for the run. So this is second point. To connect that one, that will be our graph of that equation. 8x minus 4y equals to negative 4, negative 12. So I hope you learned in this video, and thank you for watching. Good day. Today we're going to talk about graphing linear equation using slope and 1 point. Actually, there are 4 methods of graphing linear equation, which are using 2 points, using x and y intercept, using slope and y-intercept, and using the slope and a point. This is our topic to be discussed now. Okay, I have here a problem: graph the equation of the line with a given slope and a point. Okay, this is our slope, this is our point. So in this case, in graphing this one, you have to plot first the point. Okay, this is for x, this is y. So 1 for x and negative 5 for y. So this is the first point. Then the next one is our slope. Our slope is 3, which means it is 3 for rise, 1 for run. Okay. So from this point, we will go upward 3 steps. 1, 2, 3, then run 1. So this is the point, second point. Why we turn right? Because our slope is positive. So to connect that one, that will be our graph on that given slope and a point. Second, the slope is negative 2 and the point is 2 and 4. This is our x, this is our y. So 2 for x, 4 for y. So this is the first point. Then our slope is 2, negative 2, or that is 2 over 1, negative. Okay, from that, we will count 2 steps upward. 1, 2. This is negative, so we will turn right 1 step or run 1. So this is the second point. To connect that one, that will be our graph on this given slope and point. Okay, next, number 3. The given is slope equals to negative 1/2 and a point 0 and 4. This is our x, this is our y. Okay, so 0 for x, 4 for y, this one. Then our rise is 1 step, 1. Then our run is 2 to the left because it is negative. So 1 and 2. So this is the second point. To connect, that will be our graph for number 3. Number 4. Okay, the given is slope equals to 3 over 3 halves and the point 2 and negative 3. This is our x, this is our y. Positive 2 for x, then negative 3 for y. Okay, this is the one. Then our rise is 3, so we'll count 3 steps. 1, 2, 3. Then positive, run is 2, so to the right. 1, 2. So this is the second point. To connect, that will be our graph on that given. Okay, last one. The graph equation of the line with given slope and a point m equals to negative 5 over 3 and a point 0 and negative 3. This is our x, this is our y. Okay, so 0 and negative 3 is 1. Then, how many? Rise is 5, so we'll count 5 steps. 1, 2, 3, 4, 5. Okay, the run is 3, negative, so we'll turn 3 steps to the left. 1, 2, 3. So this is the one. This is the second point. Second point. To connect that one, that will be our graph for number 4. Okay? Okay. That's the 5 examples for graphing slope and a point. I hope this video is a useful one for all of you who are seeking for the solution of your problem regarding graphing. So as I said, there are 4 graphing methods of the linear equation. So I hope you saw that 4 videos of mine, and thank you for watching this. God bless and thank you. Good day. Hello, good day. For today's lesson is all about finding equation of a line. There are 3 ways of finding the equation of a line. The first one is slope-intercept form, which is y equals to mx plus b. The second one, point-slope form, which is y minus y sub 1 equals to m times quantity x minus x sub 1. And the last one, two-point form, which is y minus y sub 1 equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 times quantity x minus x sub 1. Okay, we will first talk about slope-intercept form. We have here an example. Find the equation of a line whose slope is m, or m is equals to 3, and y-intercept b is 5. So, meaning to say, from this question, our given is m equals to 3, and our y and our b is equals to 5. Using the formula y equals to mx plus b, so we just simply substitute its value of m and b. So for m is 3. Then copy x, then plus the value of b, which is 5. So from that question, our answer is equals to y equals to 3x plus 5. Okay, that is the slope-intercept form of the given. Okay, number 2. Find the equation of a line whose slope m is 2 and y-intercept b. So by writing the given, we have m 2 and b is negative 4. So by substitution, we have 2 for m, then copy x, then plus minus negative 4 for b. By simplification, we have 2x positive times negative, that is negative 4. So this is the slope-intercept form of the given problem. Number 3. Find the equation of a line whose slope m is equals to 1/2 and y-intercept equals to 3. So our slope is equals to 1/2, then our b is 3. So by the formula of slope-intercept form, we have y, then substitute the value of m, which is 1/2, then x, then plus the value of b, which is 3. Okay, this is the answer for that problem. Okay, the second one is the point slope form. Y equals to y sub 1 equals to x times quantity x minus y sub 1. Okay, here is the problem. Find the equation of the line of the point slope form given m equal to 6 and point 3 minus 4. So our m there is 6, then our point is 3 and negative 4. So using the formula, our point is 3 and negative 4. Then the formula is that one. So our y sub 1 is, this is your x sub 1, y sub 1. Our y sub 1 is negative 4. Negative 4. Then our m is 6 quantity x minus y sub 1, which is 3. So simplify, this is negative times negative, this is positive 4 equals to 6 times 6, that is 6x. Then 6 times negative 3, that is negative 18. Okay, we will transpose this figure to the other side. That will become x minus 18 minus 4. So the answer is 6x. Since they are having the same sign, so we will add, that is negative 22. Okay. Then the second one is, our given is, this is 5. 5. Our m is 5. Then our point is 0. So using the formula, by substitution, we have this one, our sub x sub 1 and y sub 1. So minus 4 equals to 5x minus x sub 1, 0. So by simplification, we have y equals to 4, then 5 times 6 is 5x, and 5 times 0 is negative 0. Okay, then transpose this one to the other side, that is 5x minus 0 plus 4. So the answer is 5x plus 4. Okay, this is the answer. Then the third one is find the equation of the line or the point slope form given a 1/4 for m or slope and a point of 24 and 2. So using the same formula, we have, this is our x sub 1, this is our y sub 1. Okay, by substitution, we have y sub 1, which is 2, and our slope is 1/4 times x minus x sub 1, which is negative 24. So this is negative 2, 1/4 times 6, that is 1/4 x, and this one negative times negative is positive 24. Positive 24 times 1/4, that is positive 6. Okay, positive 6. Okay, simplify again. We transpose this one to the other side. That will become 1/4 x plus 6 plus 2. So the answer is equals to 1/4 x plus 8. So this is the answer for given number 3. Okay, another topic is two-point form, which is equals to y minus y sub 1 equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 times quantity x minus x sub 1. Okay, here's just a given. Find the equation number line, 2 points form given 2 points 3 and 4 and 4 and 7. Using this formula, okay, this is our x sub 1 and y sub 1. This is our x sub 2 and y sub 2. Okay, y minus y sub 1 is 4. Then y sub 2 is 7 minus y sub 1 4 all over x sub 2 is 4 minus x sub 1 which is 3. Then times x minus x sub 1 which is 3. Okay, simplify. This is minus 4 equals to 7 minus 7, that is 3. Then 4 minus 3, that is 1. Then times x minus 3. So y minus 4 times 3 x minus 3. So this is y4 minus 3x minus 9. So y, they transpose this one, will be transferred to the other side. It will become 3x minus 9 plus 4. So the answer now is 3 y equals to 3x minus 5. Okay, this answer to number 1. Number 2. Number 2, the given is 2-point form. For point 1 or point A is we have 4 and 25, and for B 10 and 7. Using same formula, this is our x sub 1, y sub 1, x sub 2, and this is our y sub 2. By substitution, we have y sub 1 is 25, then equals to y sub 2 which is 7 minus y sub 1 25 all over x sub 2 which is 10 minus x sub 1 4. Then quantity times quantity x sub 1 4. Okay, let us check one. The substitution if it is correct. Y sub 1 is 25, then y sub 2 is 7, y sub 1 is 25, then x sub 2 is 10, x sub 1 is 4. X sub 1, okay. So simplify. Y minus 25, this is negative 18. This is 6. Then times x minus 4. Y minus 25. 18 divided by 6. It is negative 3 times x minus 4. Okay. Then y minus 25 equals to negative 3x positive 12. So simplify again. Negative 3x plus 12 plus 25. So when you transpose this one to the other side, from negative it will become positive. So y equals to negative 3x. This will be added, that is positive 37. Okay, this is the answer. Okay, last one. Find the equation line of 2 points for given 2 points. Point A 33 and 5 and B 36 and 6. So using the same procedure, this is our x sub 1, y sub 1, this is our y sub 2 and x sub 2 and y sub 2. By substitution, we have value of y sub 1 is 5, y sub 2 is 6, minus y sub 1 5, all over 36 y sub 2, y sub 1 is 33, times quantity x minus x sub 1, which is 33. Okay, so copy 5, in that one is 1, this one is 3, times x minus 33. Okay, simplify. Y plus minus 5 equals to 1/3 x negative 11. Okay, then y equals to 1/3 x minus 11, from positive to become positive 5. Then y equals to 1/3 x subtract negative 6. This is the answer. Okay, that is how to find the equation of a line using the 2-point form, the y-intercept form, the slope form, and a point. So I hope this video could help you to solve for finding the equation of a line using those three methods. For now, thank you for viewing my video. Good day, guys, and take care. Keep safe. Hello, good day. For today's lesson is about inequality symbols and interval notations. Okay, inequality problems. We usually encountered these different inequality symbols. This one is what we call the not equal sign or symbol. This one is less than. This one is less than or equal to. And this one is greater than. And the last one is greater than or equal to. So these are the common symbols you will encounter when you solve for inequality problems. Okay, I have here a line number containing 0 from 0 to the right are positive numbers, from 0 to the left are negative numbers. In which, from this line number, we will put those solutions from the inequality problems. Okay, for example, we have this one and this one. So we will determine what are the values or the solution of that number, of that equation, inequalities. So in writing for the interval notation, we will consider these symbols. So actually there are two ways in writing. The first one is the interval notation and the set notation. So for now, we will only study first how to write the interval notation. Okay, so before writing the interval notation, we have first to understand what this symbol is all about. Okay, this one is what we call open. Usually, when a symbol is open, we will use parentheses. When the symbol is something like this, it is referring to a close. Once it is closed, we usually use the bracket. Okay, going back to the problem, we notice that this one and this one are open. So when this one and this one are open, which means that all the values here where it is located is not included in the solution. Only those number before this one and after this one. Okay, this number here are included in the solution. So to write for the interval notation, we will first write the open parenthesis as it is referring to this. Then you will write -3, comma 3 in parenthesis. So in this case, you can determine automatically by looking at this one that this -3 is not included in the solution as well as the 3 because of parenthesis and this symbol, open circle. Okay, next one. Example, second example is that one, and there we will determine what are the solution of that inequality. Okay, in writing the interval notation, so remember this one that this is referring to close, so we will use the bracket. So in writing that one, we will write the bracket first, which means that -1 is included in the solution. In comma 5, then bracket, which means that all of these are included in the solution. Okay, next problem. Okay, something like that. Then, okay, as you can see, that in our line graph, from this point up to positive infinity, no? Positive infinity, meaning from 0 going to the right are all positive, and this is going to infinity, meaning there is no bound. So how to write the interval notation when it is unlimited or there is no bound? So we notice that our point is closed circle, so we will use the bracket. Okay, to write for our interval notation, we will first write the bracket. Then after, we will put -1, comma, positive infinity, then this one, parenthesis. Why parenthesis? When it is infinite, or when the symbol is infinity, meaning you will use the parenthesis. Remember, when it is referring to infinity, you will use parenthesis, not the bracket. Okay, next one. How about this one? So, open circle going to the left, going to negative infinity. So, in that case, in writing for, again, and the other one is from 2 to positive infinity. So, how to write your interval notation using this kind of solution? So, first, we have to write the parenthesis. As I said, when it is negative infinity or positive infinity, you have to use parenthesis. So for this, we have negative infinity, comma, then this one, -2. -2, then since this is open, you will use parenthesis. Okay, we notice that we have 2 points used to infinity. So we will use the symbol union, which means there are two sets of points we consider. So from here we have close. So when it is close, we'll use bracket. Then this one, then comma, to positive infinity, then close parenthesis. Okay, next. Okay, the last number is this one. From that point, going to that point, then this point to infinity. How to write the interval notation for that? Okay, first we will write parentheses, open parentheses, because this point is, that point is open circle. Then -5, comma, -1, bracket. Why bracket? Because it is a closed circle. Then union, open parenthesis, then 2, then comma, positive infinity, parenthesis. Okay, that is how to write for the interval notation from the solution of a certain inequality problem. So I hope in this video you learned how to write interval notation. So the next topic for this is the second way of writing interval notation, the set notation. So you can find that video in my YouTube channel. For now, thank you and God bless. Hello, good day. For today's lesson is about interval notation and set notations. I have here a graph containing these points. Okay, in our previous discussion, we discussed the different symbols in interval notation. So, in this case, we have this symbol which means open, and once it is open, we'll use parentheses, and this symbol stands for close. When it is closed, then we will use the bracket. Okay. In writing for the interval notation for this graph, then we will use the parentheses because this is open circle or open point. Open, then the equivalent value, which is -3, comma, then +3, then open parentheses. Okay. In writing the set notation, we will use the brace. Then the value of x is such that x is greater than -3 and less than +3. Okay, that is how to write for the set notation based on this given solution. Okay, to read this one, this is a set of all x's such that x is greater than -3 but less than +3. In other words, the value of the solution or your x is between -3 and +3. Okay, the second one is this one, this point and that point. Okay, to write for the interval notation for that, we will use the bracket. Then the equivalent value of the first point, which is -1, comma, then the second point, which is 5, in bracket. I use bracket because all of them are close point or close circle. Then, in writing the notation, we will use again the brace, then x such that x is greater than or equals to -1, but not more than +5. Then close. Okay, third example. Our point is there plus to infinity. So to write for the interval notation for that, we will write parentheses, then -1, then comma, to +infinity, then parentheses, close parentheses. To write for the set notation, we will write there the brace, then x, such that x is greater than -1. So that is how to write for the interval and set notation for that graph. Okay, the next one, that one to infinity again. So this time, this is close. So to write the interval notation for that, we will use the bracket, then the equivalent value of -1, then comma, then to +infinity, then parentheses. To write for the set notation, the brace x such that x is equals or greater than -1. Okay, number 4. Okay, let's say that is the point to -infinity, then the second point to +infinity. Then to write for that is open parenthesis, -infinity, comma, -2, then close parenthesis. Since we have two sets, we will use unions symbol. Okay, then bracket, y bracket, because it is close. Then the point is 2, then comma, to +infinity, close parenthesis. Okay, that is how to write for that based on this graph. Then the second is set notation. The same, you write the brace, then x such that x is less than -2, or your x is greater than 2. Okay. Then the last number is this one. The points are from there -5 to -1. Okay. Then the second one is from +2 to infinity, +infinity. To write for the interval notation for that, we will use parentheses. Then the equivalent value is -5, then comma, -1, then bracket. Y bracket is this close point. Then union, open parenthesis, 2, comma, then to +infinity, then close parenthesis. To write for the set notation, the brace, then all x's such that x is greater than -5, but not more than -1. I mean to say that your x is between -5 and -1. Or this point, your x is greater than 2. Okay, that is how to write the interval and set notation of a particular solution of a certain inequality problems. So by using this set notation, you can determine what are the values of x that can be used in the final answer of your inequality problems. Okay, so for now, thank you for viewing my video. Until next, goodbye and God bless.
Hello, good day. for today's lesson is about solving rational inequalities. In solving for rational inequalities, we have to follow steps. And the first step is put the rational inequality in the general form where greater than symbol can be replaced by these three symbols, which are less than or equal to, and greater than or equal to in this form. Okay, the second one is write the inequality into a single rational expression on the left hand side. Then set the numerator and denominator equal to 0 and solve. The values you get are called critical values. Plot the vertical values on the number line, then breaking the number line into intervals. Substitute the critical values to the inequality to determine if the endpoints of the interval in the solution should be included or not. Select test value in each interval and substitute those values in the inequality. Take note that if the test value makes the inequality true, then the entire interval is a solution to the inequality. And if the test value makes the inequality false, then the entire interval is not a solution to the inequality. And lastly, use the interval notation to write the final answer. Okay, these are the steps in solving for rational inequalities. Now, we try to use this step in solving the first problem. Okay. So our first problem is 3 over x minus 2 less than or equal to -1. So the first step is to rewrite this into general form. So we will copy 3 over x minus 2, then we will transpose this one to the left hand side. From negative, that will become positive 1 less than or equal to 0. Then we will add this 3 over x minus 2 by 1, but we cannot do that because they have different denominator. So we will try to find the LCD, the least common denominator. So for that, our least common denominator is x minus 2. Okay. X minus 2 divided by x minus 2, that is 1. Okay. So we will multiply 1 by 3. Then copy the sign. Then we all know that in every whole number there is an imaginary denominator of 1. So we will divide that one with the LCD. So 1 x minus 2 divided by 1, that is x. So we'll copy this one, then this one. The quotient of dividing x minus 2 by the denominator of 1. So that is x minus 2 less than or equals to 0. Then after that, we will simplify. 3 times 1, that is 3. Then 1 times x, that is positive x. Then 1 times -2, that is -2. Then copy the denominator, x minus 2 less than or equals to 0. Then after that, we will combine like terms. So for x, we have the x variable there, so we will just copy that one. Then x, positive x and -2, that is positive 1 all over the LCD, minus 2 less than or equals to 0. Then after that, we will equate the numerator and denominator to 0. Okay, let's start with the numerator.
numerator is x plus 1 equals to 0. So we'll find the value of x. So this is equals to negative 1 because we transposed 1 to the other side, or right hand side of our equation, that will become negative. So this is the value of our numerator variable, which is x equals to negative 1. For the denominator, we have x minus 2 equals to 0. So that will become x equals to 2. So this is the two values of our x now. Negative 1 and x equals to positive 2. Okay. After knowing the values of x in the problem, we will try to use this one in our inequality if these numbers are really part of the solution of the problem. Okay. So we will try to use this one as the value of x. Okay, let's say from there we have x negative 1. So if x is equals to negative 1, by substitution with this, with that, so this is negative 1, then plus 1 over negative 1 negative 2 less than or equals to 0. Then simplify negative 1 plus positive 2, that is 0. Then negative 1 and negative 2, that is negative 3 less than or equals to 0. When you divide 0 by any number, that is, the answer is always 0. So for this, we have 0 divided by negative 3, that is 0. So, okay, from this result, 0 is less than or equals to 0, which means that this value of x equals to negative 1 resulting to 0 less than or equal to 0 is true. So we will put there close circle or close point. Remember that when the value of x is true, we will always use a close circle. But when the value of x resulting to false, you will use a circle or point, an open point or open circle. Okay, how about this one? X equals to 2. Okay, so by substitution, use the same inequality. The value of x is 2 plus 1 divided by 2 minus 2 less than or equals to 0. By simplification, 2 plus 1, that is 3. Then 2, positive 2 and negative 2, that is 0. Less than or equal to. So any number which will be divided by 0, the answer is undefined. So for this is undefined. So less than equals to 0. So remember, this is not true. This is false. So when the value of x is 2, the answer is undefined. It will result to false. So I mean to say that 2 is not included in the solution. So we will only put an open circle. So as you can see, the first one is closed circle and the second one is open circle. When the point or the circle that we use in the number line is closed, which means that that number is included in the solution. Whereas if it is open, then that number is not included in the solution. Okay. So next step is to determine each interval
of this number line. So as you can see, we have 3 intervals. This is the first, second, and third. Okay, we will try to test each interval if they will result to a true result, meaning we will test those numbers in each interval if it is if the answer is true, or if that number can be used as the value of x. Okay, so let's try to the same inequality. We will use this one, no? Then we will try to find this area. So this area stands for x less than -1. So we will test the value of x which is less than 1 from here up to there, up to infinity. Okay, we will try to use the value of x equals to -4. What will happen? Okay, by substitution, let's say value of our x there is -4. So -4 plus 1 over -4 minus 2 less than or equals to 0. Okay, so by simplification, we have -4 and +1, that is -3, all over -4 and -2, that is -6, less than or equals to. Then after, we will simplify this one, reduce to lowest term. So this is equals to +1/2, less than or equals to. Okay, let's try to analyze. Is 1/2 is less than or equals to 0? This is false, because 1/2 is greater than 0. So I mean to say, this part from this point up to infinity, negative infinity, is not a solution. Not a solution. Okay, how about this one, where x is between -1 and +2? Okay, we will try. We will choose, let's say, 1. X is equals to 1. Okay, by substitution, using this again, that is 1. X is 1 plus 1 all over x, which is 1 minus 2 less than or equals to 0. By simplification, we have 2, this one, -1 less than or equals to 0. So by simplification, this is equals to -2 less than 0. Is -2 less than or equals to 0? Yes, it's less than. -2 is less than -0. -2 is less than 0. So this is true. So I mean to say, this is a solution, no? A solution. This is a solution. Okay, how about this one, where x is greater than 2? So you have to consider from this point up to positive infinity. Okay, let's try to use 3. X equals to 3. Okay, so the same inequality problem. So we'll try to substitute. X is 3 plus 1 over 3 minus 2 less than or equals to 0. Okay, so by simplification, we have 3 plus 1, that is 4. Then 3 and -2, that is 1, +1, less than or equals to 0. By simplification for this, that is 4. 4 is less than or equals to 0. Is this true? This is false because 4 is greater than 0. Okay, not a solution. Okay, so only the middle interval is a solution to our inequalities. So any number here from -1 up to before any number between -1 and 2 is a solution to the inequality problem. So to write for the interval notation for this, we have -1, so -1 bracket, then comma 2. This is the interval notation. Okay, so why I use bracket here, not parenthesis, just like 2? It's because in this case -1 is included in the solution. That's why I use bracket, whereas in 2 I use close parenthesis because 2 is not included in the solution. Okay, so I hope you understand with the first problem. Okay, next one. The second problem is 3x plus 1 over x minus 2 greater than or equals to 2. So the same procedure, we will rewrite this one to general form. 3x plus 1 over x minus 1 minus 2 greater than 0. Okay, so in this case there are two terms, no? Expression, expression. So we have to find the LCD here. The LCD is x minus 1. Then we divide this with the denominator of the given. So x minus 1 divided by x minus 1, that is 1. So we will multiply 3x plus 1 by the quotient of this denominator of the denominator and LCD, which is 1. Then next, so as I said that any whole number, there is an imaginary denominator. So we will divide this one by 1. So the answer is x minus 1 close parenthesis, then copy this one, 2, then greater than or equals to 0. Okay, after that we will simplify. So 1 times 3x, that is 3x. 1 times 1, that is positive 1. Then negative 2 times x, that is negative 2x. Then negative 2 times negative 1, that is positive 2 all over x minus 1 greater than or equals to 0. Then after, we will combine all like terms. So for this we have 3x and negative 2x. The remaining is x. Then 1 and positive 2, that is positive 3 all over x minus 1 greater than or equals to 0. Next is we will equate the numerator and denominator with 0. So first, the numerator x plus 3 equals to 0, then your x is equals to negative 3. So this is the first value of x. Then second is the denominator, which is x minus 1 equals to 0. Then we will find the value of x, that is x equals to 1. Equals to 1. Okay. So we have two values of x now. The first one is x equals to -3 and x equals to +1. Okay, we will use this one. We will plot this one in the number line. But before that, we are going to substitute this one first in our inequalities to find out if that number is included in the solution. Okay, so first we have x equals to -3. So this is the result, no? The value of x, our numerator, and the denominator. So we will try to use this one as the value of x in our result. So x is -3 plus 3 all over -3 minus 1 greater than or equals to 0. So -3 plus 3, that is 0, over -3 and -1, that is -4, greater than or equals to 0. So this is 0, negative or equals to 0. Okay, is 0 greater than or equals to 0? Yes, it's true. True. So we will write there close parenthesis. How about x equals to 1? X equals to 1. So by substitution, we have 1 plus 3 over 1 minus 1 greater than equals to 0. So 1 plus 3, that is 4. 1 minus 1, that is 0. So equals to 0, greater than equals to 0. Then 4 divided by 0, that is undefined. So undefined is equals to 0. This is false. False. Okay, so we will put there open circle or open point, because this value of x, which is -3, is included in the solution, whereas 1 is not included in the solution. That's why I put there open circle. Okay, so we'll now check its interval. Okay, we have 3 interval again. Now the first and the second and third interval. Okay, so we will now try to find if the value of the first interval is a solution to the problem. Okay, this is our first interval where x is less than -3. So I use this -3 because this is this point. Negative because we will test the value of x from this point up to negative infinity. Okay, let's say 5, -5. X equals to -5. Okay, by substitution, we have this one, that is -5 plus 3 all over -5 and -1 greater than or equals to 0. By simplification, -5 and +3, that is -2 over -5 and -1, that is -6 greater than or equals to 0. By we have, okay, 2 divided by 6, -2 divided by -6, that is positive 1/3 greater than or equals to 0. Okay, excuse me. Okay, this is now our result. Is 1/3 greater than or equals to 0? Yes, this is true. This is true.
Okay, this is true. So let me check this one, because in our previous slide that is included in the solution, so I forgot to change this one. So this is closed circle. Okay, so mean to say that this portion up to negative infinity is solution to the inequality problem. Okay, how about the secant interval, the center, where x is between negative 3 and 1. We will try to use, let's say, 1, negative 1. Let's say the value of our x is equals to negative 1. Okay, by substitution, we have negative 1 plus 3 over negative 1 minus 1 greater than or equals to 0. Negative 1 plus 3, that is positive 2. The negative 1 and negative 1, that is negative 2. Less greater than or equals to 0. The answer is negative 1 greater than or equals to 0. So our result tells us that negative 1 is greater than or equals to 0. Is that true or false? That is false, because 1 is less than 0. Okay, how about the third interval? So in the third interval, this is x is greater than 1. So meaning from this point up to positive infinity. So let's say the value of our x is, let's say, 3. So by substitution, x is 3, then plus 3 over 3 minus 1 greater than or equals to 0. Okay, by simplification, 3 plus 3, 6. Then 3 minus 1, that is 2, greater than or equals to 0. By simplification, this is equals to 3, greater than or equals to 0. Is 3 greater than or equals to 0? This is true. Okay, meaning to say this is a solution. This one is not a solution. Okay, so after that, after knowing the interval which is part of the solution, we have to write our interval notation now. Interval notation. Okay, our interval notation, this one is closed circle, so we will use bracket, then the corresponding point, negative 3, comma, then this one, 1, then parenthesis, because it is open circle. So this is how to solve the secant problem, which is 3x plus 1 over x minus 2 greater than or equals to 2. Okay, so if you have question for this, just keep it, then after the video will be finished, then you can write the comment below. Okay, the last example is x over x minus 2 less than 3 minus 2 over x minus 2. Okay, same, no? You have to convert that one to general form. Okay, we will write that one x over x minus 2, then minus 3, then plus 2 over x minus 2 less than 3. Okay, so after that we will find the LCD, the least common denominator. Our least common denominator for this is x minus 2. So x minus 2 divided by x minus 2, that is 1. So that is 1 times x. Then this one, as I said, there is an imaginary denominator for every whole number. So x minus 2 divided by 1, that is 1. So my negative 3 times x minus 2, then plus this one kana siya, then you will x minus 2 divided by x minus 2, that is 1, then times 2 times 1. Okay, less than 3, less than 0, sorry, this is not 3, this is not 3. This is not 3. Okay, that is 0 0 0. Okay, after that we will simplify. 1 times x, that is x, minus 3 times x, that is negative 3x, negative 3 times negative 2, that is positive 6, then 2 times 1, that is positive 2, all over x minus 1 minus 2 less than 0. So after that one, you combine all like terms. Okay, so we have x minus 3x, that is negative 2x, then this one, that is positive 8. So over x minus 2 less than 0. So next is we will equate the numerator and denominator with 0. So negative 2x plus 8 equals to 0. So negative 2x equals to negative 8. Then we will divide both sides by negative 2, negative 2. The result is x, then 4. Okay, this is the first value of the numerator. The second one is x minus 2, which is equal to 0, then x is equals to positive 2. So these are the two values of x equals to 4 and x equals to 2. Okay, so next is we will test that value if those values of x are included in the solution. Okay, so we will use this one, negative at x equals to 4, then by substitution we have negative 2 times 4 plus 8 all over 4 minus 2 less than 0. Okay, by simplification we have negative 2 times 4, that is negative 8, plus 8 all over 2 less than 0. Negative 8 and positive 8, that is 0 over 2 less than 0. Then 0 divided by 2, that is 0. Is 0 less than 0? This is false. false. So meaning to say, the value of 4 is not included in the solution. So we will write, no, we will write there open parentheses. So next is 2. When x is equals to 2, by substitution we have negative 2 times 2 plus 8 all over 2 minus 2 less than 0. By simplification we have negative 4 plus 8 0, then equals to 0. So negative 4 and positive 8, that is 4, positive 4 over 0 is done 0. So 4 and 4 divided by 0, that is undefined. So this is also false. That's why we have two open circle in the number or the value of our x. So since they are not included in the solution, we will try to find out what are those numbers which are part of the solution. So we will determine how many intervals are there. Okay, there are 3 again. The first one is that, second and third. Okay, we will determine there what are the values of x that can be used as the value of x in the inequality problem as part of the solution. Okay, so here in the first interval, our x is less than 2. Okay, from this point up to negative infinity, from positive 2 to negative infinity. So we will try to use 0, x equals to 0. From this inequality, 2x plus 8 over x minus 2 less than 0, negative 2, then the value of x is 0, plus 8 all over 0, negative 2 less than 0. So negative 2 times 0, that is 0 plus 8 over 0 minus 2, that is negative 2 less than 0. So let us check. Negative 2 times 0, that is 0 plus 8. Okay, 0 minus 2, that is negative 2. So by simplification, we have 8 and negative 2 less than 0. Then 8 divided by negative 2, that is negative 4 less than 0. Okay, is negative 4 less than 0? This is true. Negative 4 is less than 0. So this first interval is solution to a problem. So any number here from 2 to negative infinity can be used as the value of x from the given inequality. Now the second interval. The second interval is our x is between 2 and 4. So we will try to use 3. Now x equals to 3. Okay, by substitution we have 2 times 3 plus 8 all over 3 minus 2 less than 0. Okay, then simplify. Negative 2 times 3, that is negative 6 plus 8 all over 3 minus 2, that is 1 less than 0. So negative 6 plus 8, that is 2 over 1 or 2. Okay, less than 0, 2. Okay, is 2 less than 0? This is false. So I mean to say this is not a solution to the problem. Okay, last interval, this part. So our x here is greater than 4. Let's try to check if this interval are a solution to the problem. Okay, let's try to use 6. X equal to 6. By substitution, we have negative 2 times 6 plus 8 over 6 minus 2 less than 0. By simplification, negative 2 times 6, that is negative 12 plus 8 all over 6 minus 2, that is 4, positive 4 less than 0. Negative 12 minus plus 8, that is negative 4 over 4 less than 0. This is negative 1 less than 0. Okay, is negative 1 less than 0? Yes, it's true. Okay, so meaning to say, this interval from 4 to positive infinity are also part of the solution of the given inequality. This is a solution. Okay, and the last part is to write the interval notation. Interval notation. So in that case, since both points are not included, we will use parentheses for both points. So we have 2 comma 4 parentheses. Okay, so that's all the process on how to solve for an inequality. So I hope this video would help you in solving your mathematics problem in your modules nowadays, and thank you for viewing my video, and hope and expect that you would also view or see my next video regarding next topic after the inequality in your curriculum. For now, I will say thank you and God bless. Once again, good day.
Good day. For today's lesson is about the greatest common monomial factor. How to find the greatest common factor of a monomial expression?